Have you ever looked up at the night sky and felt a profound sense of betrayal? The stars you see, the silver constellations you map with your eyes, they are not really there. At least, not as they appear in this exact moment. You are staring into a massive, glittering graveyard of time. Every twinkle is a phantom, a chronological ghost delivering a message from an era that has long since burned away into the dark. Welcome to a journey into the incomprehensible. Tonight, we are going to slowly descend into the true scale of the cosmos, a place where the word big loses all meaning, and the human mind is forced to confront its own absolute fragility. We are going to travel outward, leaving the comfortable illusions of our daily lives behind, to measure the abyss. As you listen to my voice, I want you to forget the walls around you. Forget the city you live in, the continent you stand on, and the planet that anchors your feet. Let your mind drift into the cold, quiet expanse. When we try to understand the universe, our brains immediately fail us. We are creatures built to understand the distance to the nearest river, the time it takes to walk to the next valley, or the speed of a predator in the brush. We are not built to comprehend trillions of kilometers. So, we must invent a new language. We must speak in the tongue of light. Light is the ultimate speed limit of reality, tearing through the vacuum at nearly 300,000 kilometers every single second. In the time it takes you to blink, a beam of light could circle the Earth 7 times. It is the fastest thing in existence, and yet, against the terrifying canvas of the universe, light is agonizingly slow. Let us start close to home. The moon, our pale and silent companion, sits just over 1 light second away. When you look at the moon, you are seeing it exactly as it was 1 second in the past. It feels immediate, but it is already a memory. Now, cast your gaze to the sun, the blazing nuclear furnace that holds our world in its gravitational grip. The light warming your skin left the surface of the sun 8 minutes ago. If the sun were to suddenly extinguish, instantly winking out of existence, we would not know. For 8 minutes the sky would remain blue. The birds would still sing. We would continue to live in the ghost of its warmth, completely oblivious to the apocalyptic darkness rushing toward us through the void. That 8-minute delay is our first true taste of cosmic isolation. Everything we know about space comes to us after a journey, and the universe is simply too large to ever feel immediate. Now, let us push further out. Imagine leaving the warmth of the inner solar system behind. We pass the rust-red deserts of Mars, the swirling violent storms of Jupiter, and the delicate icy rings of Saturn. The light from the sun grows weak, shrinking until it looks like nothing more than an exceptionally bright star in a pitch-black sky. We arrive at Neptune, the last true planet, a frozen blue leviathan howling with supersonic winds. It takes light 4 hours to reach Neptune from the Sunday. If Earth were the size of a coin sitting in the palm of your hand, Neptune would be hundreds of meters away. And yet, we have barely stepped off the front porch. Beyond Neptune lies the Kuiper Belt, a vast, chaotic ring of frozen debris, dwarf planets and ancient ice. But the true border of our solar system is much, much further. It is a theoretical shell of trillions of icy comets known as the Oort Cloud. To reach the outer edge of this frozen bubble, you would have to travel for an entire year at the speed of light. 1 light year. 10 trillion kilometers, just to leave our own backyard. Humanity has sent mechanical emissaries into the dark. The Voyager probes, launched decades ago, are hurtling away from us at over 60,000 kilometers per hour. They are the fastest, furthest machines we have ever built. But at their current speed, it will take them tens of thousands of years just to clear the Oort Cloud. For humanity, a light year is an eternity. For the universe, it is a microscopic fraction of an inch. Let us leave our solar system behind entirely. We drift into the interstellar medium, the vast, silent ocean between the stars. The nearest star to our Sun is Proxima Centauri, a dim red dwarf sitting 4 light-years away. If you were to look at Proxima Centauri tonight, the light hitting your retina began its journey 4 years ago. You are never seeing the universe as it is. You are only ever seeing the universe as it was. Stargazing is, in its purest form, time travel. But Proxima Centauri is merely our next-door neighbour in a sprawling, unimaginably crowded metropolis. We live in the Milky Way, a spiralling disk of starlight, gas, and dark matter that spans 100,000 light-years across. Picture that in your mind. A wheel of glowing dust and burning spheres so wide that a beam of light, the fastest messenger in nature, takes 100,000 years to cross from one edge to the other. Human civilization, all of our recorded history, our wars, our empires, our art, and our tragedies, has only existed for a fraction of that time. And inside this glowing wheel are hundreds of billions of stars. Pause for a moment and let that number settle in your chest. Hundreds of billions. If you were to count one star every second, without ever stopping to sleep or eat, it would take you over 3,000 years to count the stars in our galaxy alone. And most of these stars are not alone. They have planets, rocky worlds, gas giants, frozen spheres, and boiling hellscapes. There are more planets in the Milky Way than there are grains of sand on every beach on Earth. We sit in a quiet, unassuming suburb of this galactic city, positioned on a minor spiral arm called the Orion Spur. It is a safe distance from the chaotic, violent center of the galaxy, because at the very heart of the Milky Way, hidden behind thick veils of glowing dust, lies a monster, Sagittarius A star, a supermassive black hole millions of times heavier than our Sunday. It is a gravitational abyss, a tear in the fabric of space-time where light itself is swallowed forever. It anchors our galaxy, a dark sovereign holding billions of stars in a slow, 200-million-year orbit. But the Milky Way, for all its terrifying grandeur, is just a single drop in an endless cosmic ocean. As we zoom out further, our galaxy becomes part of a small neighborhood known as the local group. Here, we find our massive neighbor, the Andromeda galaxy. Andromeda is 2.5 million light-years away. When you look at its faint, fuzzy glow through a telescope, you are seeing light that left its stars when early hominids were just learning to walk upright on the African savanna. But Andromeda is not just sitting there, it is falling toward us. In about 4 billion years, the Milky Way and Andromeda will collide. It will not be a sudden, violent crash, but a slow, majestic, and terrifying gravitational dance. The night sky on Earth, if anything is still alive to see it, will be completely dominated by the glowing core of Andromeda as the two galaxies rip each other apart and merge into a single massive elliptical galaxy. It is a reminder that the universe is not a static painting. It is a violent, churning engine of creation and destruction. We step back even further. The local group is just a tiny cluster on the edge of the Virgo supercluster, a gathering of thousands of galaxies, and the Virgo supercluster is merely a single branch of Laniakea, an immeasurable structure containing 100,000 galaxies stretching across 500 million light-years. The name Laniakea translates to immeasurable heaven, and as we map these superclusters, a terrifying and beautiful pattern emerges. The universe is not a random scattering of light. It is structured. It looks exactly like a biological neural network. Vast, glowing filaments of galaxies stretch across billions of light-years, intersecting at massive gravitational nodes, separated by horrifyingly empty voids where absolute nothingness reigns. This is the cosmic web, the grandest architecture in existence, and as we trace the threads of this web, we finally hit the wall, the edge of reality as we know it. We reach the boundary of the observable universe. It is a sphere 93 billion light-years in diameter, but this edge is not a physical wall of brick or energy. It is an illusion created by the speed of light and the age of the universe. The cosmos has existed for nearly 14 billion years. That means light has only had 14 billion years to travel toward us. Anything beyond that distance is invisible, not because it does not exist, but because its light has simply not had enough time to reach our eyes. We are trapped inside a bubble of ancient light, staring at the walls of a cosmic prison, completely unaware of the terrifying and magnificent structures lurking just inches beyond our sight. This is a bigness that completely erases all the usual categories of human thought. It is not simply a larger house, a deeper ocean, or a longer road. It is a bigness that mocks the very concept of comparison itself. When faced with this unfathomable expanse, our minds naturally attempt to build mental ladders. We try to climb from the ground we know to the moon, then from the moon to the sun, then onward to the nearest stars, the local galaxy, and finally the sprawling clusters of the cosmic web. But with each step up this ladder, the rungs grow exponentially further apart. You add a zero to the distance, and then another, until the numbers entirely stop looking like physical distances and start behaving like abstract, impenetrable codes. But here lies the most curious paradox of cosmic distance. Even though our fragile human minds cannot truly picture these terrifying expanses, we possess the ability to measure them with extraordinary, almost haunting accuracy. Astronomers look at the sky and use parallax, measuring the tiny, almost imperceptible shift in a star's position as the Earth slowly orbits the Sun, calculating exactly how far away that point of light truly is. For the stars that lie deeper in the dark, they rely on standard candles, special, rhythmic kinds of stars that burn with a known, predictable brightness. By carefully comparing how bright they appear to our telescopes with how bright they actually are, scientists can estimate the vast gulfs of space between us. And for the most far-flung, ancient galaxies at the very edge of our vision, they measure the red shift of light, watching how the very wavelengths of ancient photons are stretched and distorted as the fabric of the universe expands. It is layer upon layer of clever, desperate methods, each one extending our reach just a little bit further into the dark, until we find ourselves sketching detailed maps of regions that span billions of light years. We cannot picture this scale, but we can measure it. We cannot feel it against our skin, but we can calculate its weight and its distance. And those measurements are stubbornly consistent, repeatable, and reliable. They tell us that the observable universe is about 93 billion light-years across. Just saying that number out loud feels almost meaningless. 93 billion. What could possibly compare to that? Nothing in our daily lives even briefly brushes against a fraction of that scale. Yet, it is the absolute best answer we have. It is deeply tempting to simply call this unimaginable and turn away. But perhaps the better word is unfamiliar. We can, if we are patient, imagine it in pieces. A single second of light, a minute, an hour, an astronomical unit, a light year, a galaxy. Each individual piece slots into the next, exactly like smooth stepping stones laid out across a rushing, infinitely wide river. You can never hold the entire roaring river in your mind at one time, but you can carefully make your way across it, balancing on one stone at a time. That is how science has always handled the crushing weight of scale, piece by piece, measurement by measurement, until the unimaginable becomes, at the very least, discussable. And that is exactly what we are doing together now. We are not attempting to swallow the entire staggering size of the universe in one impossible gulp, because no human mind can. Instead, we are tracing its distances step by step, marveling at how each new threshold grows unimaginably beyond the last. The more you stretch your mind to hold these cosmic scales, the more you realize just how incredibly small our familiar world actually is. But this realization is not meant to be dismissive. It is meant to be grounding. Our quiet rooms, our bustling cities, our blue planet, all of them are tiny, fragile cradles of familiarity, tucked inside a cosmos so impossibly large that it takes light itself billions of years just to cross it. So when you look up tonight, or on any clear night, and see a single star flickering in the dark, remember that what you are seeing is not simply a point of light. It is an ancient messenger. It is a traveler from the deep past, carrying news of a place you will never reach in person, but which still generously shares its story with you across the unthinkable gulfs of time and space. Each point of light has its own distance, its own history, its own silent narrative. They are not just numbers on a chart. They are part of the vast, intricate fabric of everything we are. When we speak of our lonely place in the universe, it helps to pause for a while, to take a deep breath, and linger in the neighborhood that feels closest to us. Because long before we stretch our minds into colliding galaxies and the terrifying architecture of the cosmic web, there is a space much nearer, filled with familiar companions that shape our days and our nights in ways we often forget to notice. It begins with Earth, of course, our safe and watery home, but it quickly extends outward to the strange worlds, the silent moons, and the countless smaller bodies that circle our sun together in a shared gravitational embrace. This is the patch of space we know best. Not because it is small by any normal standard, but because we have lived our entire existence beneath it. We have studied it, mapped it, and sent our fragile robotic probes to wander across its freezing deserts and toxic clouds. It is both incomprehensibly vast and strangely intimate at the exact same time. It is our cosmic front yard. Think first of the moon. It is our only natural satellite and the single object in the night sky that has most deeply and profoundly shaped the rhythms of human life. Its invisible gravity reaches across the void to tug on Earth's oceans, breathing life into the tides that wash against our shores. Its pale light, simply a reflection of the hidden sun, has guided weary travelers and nocturnal hunters for tens of thousands of years through the darkest of nights. Cultures across the entire span of human history have traced its endless cycles, marking the passage of months and the turning of seasons by the ever-changing phases of its face. In cosmic terms, it is incredibly close, sitting just 1¼ light seconds away. A radio signal beamed from Earth takes only that brief heartbeat of time to reach its dusty surface. But when the first astronauts made that perilous journey, it took them 3 long, tense days of traveling through the void. The moon is near enough that we can easily imagine standing on its craters, yet far enough that every single trip there was a monumentally extraordinary feat of human courage and engineering. And to this day, when you watch it slowly rise over the horizon, you are watching a silent companion world that circles us steadily, locked to our planet in a gravitational dance as old as the Earth itself. From the pale glow of the moon, it feels completely natural to glance toward the sun, the great blazing anchor of our entire neighborhood. Nearly all the light and warmth that makes the Earth a livable, breathing world comes directly from its violent nuclear heart. Deep within its core, hydrogen atoms are crushed together to fuse into helium, releasing a staggering amount of energy that radiates outward in a steady, blinding blaze. It is a journey of unimaginable patience. It takes a single photon hundreds of thousands of years just to wander its way out from the crushing density of the sun's core to reach its boiling surface. But once those photons finally escape, they stream through the vacuum of space at the ultimate speed limit of the universe, arriving to warm the skin on your face in just over 8 minutes. We depend on this absolute consistency more than anything else in the entire sky. The sun's massive gravity holds all the planets firmly in their orbital paths. Its boundless energy drives the winds, the weather, the miracle of photosynthesis, and the delicate balance of our global climate. It is both a completely ordinary star, just one among hundreds of billions in the Milky Way, and the single most extraordinary thing in our skies, simply because without it, we would cease to exist. Orbiting alongside us in this radiant warmth are the planets, each one a completely unique story written in rock, gas, and ice. Closest to the fire is Mercury, a small, heavily battered rock that races around the sun in a frantic 88 days. Its surface is brutally scorched by the relentless sunlight, baking at temperatures that would melt lead, yet its long, dark nights are freezing cold. These are violent extremes, born of a world with an atmosphere so impossibly thin that it cannot soften the wild swing between day and night. Then there is Venus, a world thick with choking carbon dioxide and permanently cloaked in highly reflective clouds of sulfuric acid. In terms of sheer size and mass, it is nearly Earth's identical twin, but in nature, it is a nightmare. Its runaway greenhouse atmosphere traps the sun's heat so ruthlessly and efficiently that its surface is a crushing, baking furnace. For a very long time, before our probes pierced its veil, some dreamers imagined Venus as a lush, tropical jungle world, teeming with alien rain. Now, we know it as a desolate hellscape, a haunting reminder of what a runaway climate can do to a perfectly good planet. And then, sitting just beyond our own orbit, there is Mars, red, dry, dusty, but endlessly, magnetically fascinating. Its deep, winding valleys, its colossal canyons, and its frozen polar ice caps hint at a distant, warmer past when liquid water flowed freely across its rust-coloured surface. Today, lonely robotic explorers crawl at a glacial pace across its rocky dunes, sending back hauntingly beautiful images that stir both rigorous science and wild imagination. Many dream of standing on that red dirt one day, looking back at Earth to see it as nothing more than a pale blue dot suspended in the alien sky, much as the Apollo astronauts once looked back from the desolate surface of the Moon. Mars is not close, not in the terms of human travel. Depending on the alignment of our orbits, it takes many long, isolating months to reach. But in the grand, terrifying scale of the universe, it is right next door. Beyond the rusty deserts of Mars lies a boundary, and crossing it brings us into the realm of the giants. Jupiter reigns here, a colossal sphere of swirling, violent storms and colourful, turbulent bands of gas. It is a world so massive it could swallow 1,000 Earths, accompanied by a retinue of moons that are entirely fascinating worlds in their own right. There is Europa, wrapped in a thick shell of cracked ice, but hiding a vast, dark, liquid ocean beneath its surface, making scientists wonder endlessly about the possibility of alien life swimming in its lightless depths. There is Ganymede, a moon so impossibly large that it dwarfs the planet Mercury. And there is Io, a tortured, chaotic moon, absolutely alive with erupting volcanic fire, its surface constantly remade by the gravitational tug-of-war with its massive host. Saturn follows closely behind in the cosmic hierarchy, majestic and serene with its iconic, breathtaking rings. These rings are not solid bands, but countless billions of icy particles, ranging from the size of dust grains to the size of mountains, circling the planet in intricate, shimmering arcs of light. Its largest moon, Titan, is a strange, freezing mirror of early Earth, boasting lakes and rivers of liquid methane beneath a thick, hazy orange sky. Another of its moons, Enceladus, is a tiny, brilliant white sphere that sprays towering fountains of water ice out into the vacuum of space from deep glowing cracks near its south pole. It is yet another tantalizing possible harbor for life, hiding warmly beneath the frost. The neighborhood only grows stranger, darker, and colder the farther outward we venture. Uranus is a pale, featureless blue giant, tilted so far over on its side that it appears to roll along its orbital path like a ball, a permanent scar from some ancient, catastrophic collision. Neptune sits even deeper in the dark, a world of deep, mesmerizing azure, whipped by freezing winds that howl through its atmosphere at speeds faster than the speed of sound. And circling Neptune is Triton, its largest moon, moving in the completely wrong direction against the planet's rotation, a clear sign that it was not born there, but was violently captured by Neptune's gravity from the deeper, darker regions of space. All of these worlds, each so wildly different from the last, are orbiting together in the exact same shared system, bound invisibly by the gravity of our single star. And still, our familiar neighborhood does not stop there. The dwarf planets add their own quiet, frozen stories to the cosmic map. Pluto, once proudly called the ninth planet, remains a breathtaking world of towering ice mountains and vast, smooth plains of frozen nitrogen. Eris, Haumea, Makemake, these are names less well known to us, yet each one is an entire world, silently orbiting in the freezing, twilight stretches far beyond Neptune. Together, they remind us that the solar system is not just the tidy, simplistic lineup of 8 planets we once learned in school. It is a far richer, far more chaotic family, filled with hundreds of thousands of smaller, ancient bodies. From the rocky debris of the asteroid belt churning between Mars and Jupiter, to the icy comets with their long, glowing tails swooping in from the deep dark, it is incredibly easy to forget that all of these bodies are moving together. From the sun-scorched rocks of Mercury to the frozen plains of Pluto, from Ceres in the asteroid belt to the lonely comets diving inward from interstellar space, every single one of them is orbiting around the sun. It is like a sprawling cosmic city. Every object is constantly moving in a precise path defined by the unbreakable laws of gravity. Every single one of them is tied securely to the exact same central star. To look at the solar system as a whole is to see a neighborhood in perpetual motion. The planets do not hang perfectly still in the dark void like ornaments. They are speeding along in their orbits with terrifying momentum. Mercury is whipping around the sun at a blistering pace. Neptune is crawling slowly, taking over a century to complete a single lap. Earth, our home, completes its grand circle in exactly 1 year. Each celestial body keeps its own unique rhythm, and together they form a complex, perfectly balanced dance that has gone on uninterrupted for billions of years. When you zoom out far enough, the entire solar system itself becomes just one tiny, insignificant speck among many. But from within, it is incredibly rich with detail and history. We have sent our fragile spacecraft to visit most of the planets now, and each daring mission has fundamentally expanded our view of reality. We have successfully orbited Jupiter and Saturn, plunged through the toxic clouds to land on Venus and Mars, flown past the icy heart of Pluto, and even gently touched the surface of a speeding asteroid to bring a handful of ancient dust back home. These monumental achievements remind us that while the distances inside our planetary neighborhood are still incredibly huge, they are finally within the reach of human exploration. They are no longer beyond our imagination, and they are no longer beyond our technology. They represent the very first frontier that humankind has tentatively begun to cross. And yet, even with all of this newfound familiarity, the solar system remains absolutely immense when compared to our daily earthly experience. Light takes 8 minutes to reach us from the sun. It takes a staggering 4 hours to reach the windswept clouds of Neptune. It takes more than an entire year for that same light to finally leave the outer edges of the Oort Cloud. The sheer scale of it dwarfs anything we could ever build on Earth. And yet, we still think of this massive, sprawling system as local. This is our front yard. This is our neighborhood. That phrase alone should tell you just how unimaginably big the universe beyond must truly be. If this vast, sweeping system of planets, moons, and icy debris is considered only our starting ground. Still, there is a profound comfort in knowing the intimate details of this specific region of space. We can point to a red dot in the sky and know it is Mars, and we know roughly how many months it would take to fly there. We can track the invisible orbits of near-Earth asteroids and accurately predict their paths decades into the future. We can model the erratic behavior of incoming comets. These things are no longer abstract mysteries. They are measurable, predictable, and tangible in a way that the distant galaxies and the sprawling cosmic webs simply are not. They are the solid stepping stones that lie between us and the wider, terrifying unknown. Sometimes, when you see an illustration of the solar system laid out flat on a page in a book, it looks incredibly neat and tidy, with the planets lined up perfectly in order, evenly spaced like colourful beads strung on a wire. But the actual reality of space is so much more spacious, and so much more empty. If the Earth were shrunk down to the size of a small glass marble, the Moon would be sitting just a few centimetres away. The Sun would be a massive sphere a few meters in the distance. Jupiter would be dozens of meters off, a large striped sphere rolling in the grass. Neptune would be hundreds of meters away, barely visible. And the Oort Cloud, that massive invisible shell of icy fragments that marks the true, final edge of the Sun's gravitational influence, would be kilometers away from that tiny marble. The empty space between the worlds is overwhelmingly vast compared to the tiny worlds themselves. Most of the solar system is nothing but empty vacuum, scattered only with occasional lonely travelers. That deep, silent emptiness is a fundamental part of its character. It is not a crowded, bustling neighborhood, but a deeply isolated, spread out one. Yet, for all of its terrifying emptiness, this specific neighborhood is the exact place where every single story of life we have ever known has unfolded. The Earth, with its deep oceans and sprawling green forests, the Moon, with its pale, comforting glow, the Sun, with its endless, life-giving energy. These are not just scientific landmarks plotted on a cosmic map. They are the absolute anchors of our existence. Every single breath you take, every step you walk across the ground, every night you tilt your head back to look up at the dark sky, you are sitting inside this neighborhood, moving as a part of its grand motion. And no matter how far our thoughts may eventually reach out into the dark, it is from this exact spot that we must always begin. But the farther you go from the comforting warmth of the sun, the quieter and stranger the neighborhood slowly becomes. Near Earth, space is relatively busy. Satellites orbit in a chaotic swarm, the moon hangs comfortingly close, and the sun fills the daytime sky with blinding light and heat. But as you step outward, drifting past the rusty deserts of Mars, past Jupiter with its swirling violent storms, past Saturn with its bright icy rings, you begin to notice a profound shift in the environment. The sunlight steadily weakens, fading from a roar to a whisper. The planets grow fewer, and the gulfs of empty space between them grow wider and more isolating. By the time you have reached Neptune, the last of the true giant planets, You are already floating in a place where the sun is no more than a brilliant, piercing star. It is still far brighter than any of the others against the black velvet of space, but it is no longer a blazing disk, and it no longer fills the sky with any meaningful heat. And as you drift beyond Neptune, the familiar architecture of the solar system fades almost entirely into the dark, preparing you to step over the threshold into the freezing, untamed wilderness that lies waiting in the deep. This wilderness is known as the Kuiper Belt, a staggering ring of icy bodies that stretches far beyond the orbit of Neptune. It is a realm where the concept of a familiar planet begins to fracture and dissolve into something entirely different. Here, dwarf planets like Pluto, Haumea, and Makemake drift silently in the absolute cold, accompanied by countless smaller fragments that never quite manage to pull themselves together into full-fledged worlds. Sometimes, people compare this region to the asteroid belt that sits between Mars and Jupiter, but that comparison barely scratches the surface of the truth. The Kuiper Belt is unfathomably larger, extending for billions of kilometers across the dark, containing a chaotic wealth of primordial material left over from the very dawn of our solar system. To cast your mind into this zone is to enter a desolate frontier where the worlds are small, the surfaces are locked in deep freeze, and the sunlight is so terribly weak that it offers no warmth at all. Take Pluto, for instance. Once proudly heralded as the 9th planet of our neat, orderly system, it is now understood as simply one of the brightest and most massive residents of this sprawling icy collection. Yet, it is a world of breathtaking, haunting beauty. Its towering mountains of solid water ice, its vast, smooth plains, and its slow-flowing glaciers of frozen nitrogen reveal a profound secret. Even in such brutally cold, unimaginably distant places, geology is still alive. The surface is not a dead static crater field, but a dynamic, shifting landscape. The other objects sharing this dark belt are less explored, but they are no less mesmerizing. Some are violently elongated, spinning so rapidly they threaten to tear themselves apart. Others are locked together in eternal binary embraces, two icy twins circling a shared center of gravity as they fall through the void. Many are simply too small and too distant for us to study clearly, but their mere presence serves as a humbling reminder. The solar system does not end with the tidy, predictable row of planets we learn about in childhood classrooms. It spills outward, messy and chaotic, into these frozen, uncharted frontiers. But even this vast, icy belt is not the true end. Beyond the Kuiper Belt, space becomes even emptier, the darkness even more absolute. Yet, astronomers believe that surrounding our Sun, stretching out perhaps halfway to the nearest neighbouring stars, lies an incomprehensibly massive, spherical shell of icy debris. This is the Oort Cloud. Unlike the planets and the Kuiper Belt, which mostly orbit in a relatively flat disk-like plane, the Oort Cloud is thought to encapsulate the solar system in all directions. It is a colossal, invisible bubble of comets, waiting silently in the deep dark. Its existence has never been directly observed by human eyes or telescopes. Instead, it is a ghost inferred from the long, elliptical orbits of certain comets, those rare, icy visitors that sweep inward to graze the sun only once every few thousand, or sometimes millions, of years. To send a comet on such an extreme elongated path requires a reservoir far larger and far more distant than the Kuiper Belt. The Oort Cloud, if it truly exists exactly as our mathematics suggests, would contain trillions of these icy bodies. Each one is a frozen, perfectly preserved remnant of the solar system's violent birth. Imagine, just for a moment, what it would actually feel like to drift outward toward this distant shell. For days, then months, then years, you would travel through the blackness beyond Neptune. The familiar planets would vanish behind you one by one, growing smaller and fainter until they were entirely swallowed by the dark, indistinguishable from the background stars. The sun itself would shrink in the sky, still a piercing point of light, still brighter than anything else, but stripped of its warmth, no longer the blazing, life-giving disk that dominates the sky of Earth. By the time you reach the depths of the Kuiper Belt, you would find yourself in a region that feels far more like an endless, icy desert than a crowded field of debris. The distances between these frozen objects would be staggering. Pluto, for example, is separated from its nearest neighbours by millions of kilometres of absolute nothingness. You would not see bodies clustered together like pebbles scattered on a beach. Instead, they are scattered like lonely, isolated boulders sitting on an endless, invisible plain. And as you push even further beyond that, the distances grow so terrifyingly great that the objects of the Oort Cloud would likely never even appear within your sight. Even if you were to pass relatively close to one of these trillions of comets, it might only look like a faint, ghostly speck drifting against the unmoving stars. The outer reaches of our solar system test the very limits of our imagination because they are so rarely encountered, so entirely alien to our daily experience. No spacecraft built by human hands has ever reached the Oort Cloud. A small, courageous handful of robotic explorers like Voyager 1, Voyager 2, Pioneer 10, and Pioneer 11 are currently travelling outward, escaping the sun's gravity, and they may one day enter that shadowy region. But they move with an agonizing slowness compared to the crushing scale of the cosmos. Voyager 1, the most distant and solitary of them all, launched into the sky in 1977. Since then, it has travelled more than 20 billion kilometres away from the Earth. That number sounds astonishing, and it truly is a testament to human ingenuity. Yet, by most astronomical estimates, Voyager 1 has not even come close to reaching the inner edge of the Oort Cloud. At its current blistering speed, it will still take thousands upon thousands of years just to arrive at that boundary. That single fact gives you a chilling sense of just how immense this outer shell must be. This desolate part of the solar system is also the exact place where the sun's physical influence finally begins to wane. Within the realm of the planets, space is filled with the solar wind, a relentless, invisible stream of charged particles flowing outward from the sun's turbulent atmosphere. But out here, at these great distances, the pressure of the thin, cold gas drifting between the stars begins to push back. There is a delicate, unseen boundary out in the dark called the heliopause, the exact line where the sun's wind stops dominating and the true space between the stars begins. Voyager 1 has likely crossed this invisible threshold, earning it the title of the first human-made object to enter interstellar space. Yet, even out there, in the quiet dark beyond the solar wind, the sun's gravity still holds sway. The Oort Cloud, if real, remains gravitationally bound to our star. It is still a part of our system, even if it spans light years across the abyss. These outer reaches also carry a lingering, tantalizing mystery. Some astronomers strongly suspect that there may be a massive, hidden planet lurking far beyond Neptune, a world sometimes referred to as Planet 9. Its unseen presence has been suggested by the odd, seemingly synchronized clustering of certain distant orbits in the Kuiper Belt. If this ghost world truly exists, it could be a giant, several times the mass of the Earth, orbiting hundreds of times farther from the Sun than we do, moving in the perpetual twilight of the outer system. Finding it, however, is a monumental challenge, because at such extreme distances it would be impossibly faint and slow-moving, easily lost among the glittering backdrop of countless background stars. Whether or not it is real remains a fiercely debated uncertainty. But the very fact that scientists must seriously consider the possibility of a massive, hidden planet in our own system shows just how little we truly know about our own cosmic backyard. It is worth remembering that all of these outer regions, from the chaotic Kuiper Belt to the ghostly Oort Cloud, are the ancient remnants of the solar system's original formation. 4.5 billion years ago, the Sun and the planets coalesced from a swirling, turbulent disk of hydrogen gas and cosmic dust. But not everything was neatly swept up into the planets we know today. Some of that primordial material was violently flung outward, cast away far beyond the main system by the shifting gravity of the young gas giants. Those exiled, icy fragments became the Kuiper Belt and the Oort Cloud. They are the leftovers, the frozen archives of the solar system's earliest, most chaotic days. When we observe comets streaking through the inner solar system, their ice sublimating into brilliant, glowing tails, we are touching that ancient history directly. The ice locked within them contains vital clues about the exact chemical conditions that existed when the Sun was just a newborn star. In the rhythm of our daily lives, these outer reaches can easily feel irrelevant. They are too far away, too incredibly cold, too impossibly empty to impact our morning routines or our evening plans. Yet they matter deeply because they mark the true, staggering size of our solar system. The Sun's family does not simply end at Neptune. It stretches for trillions of kilometers outward, a fading empire of gravity that eventually blends seamlessly into the stars. When you look up and catch the rare sight of a comet streaking across the night sky, with its glowing, fuzzy head and its long, sweeping tail, you are witnessing a traveler from those unfathomable distances. It is a messenger from the very edges of the solar system. Its long journey inward is a beautiful, haunting reminder that the outermost regions, though entirely unseen by our naked eyes, are real, and that they occasionally reach out to touch us. If you were somehow able to step outside the solar system entirely and look back at it from a distance, what you would see would not be a tight, brightly coloured cluster of planets. You would see a single, small star orbited by tiny, pale points of light, too faint to even notice without effort. Only with incredibly powerful eyes could you make out the wide, dusty disk of debris, and the faint spherical halo of the Oort Cloud surrounding it all. From that godlike vantage point, even the outer reaches of the solar system would look small, a tiny bubble in a vast ocean. And yet, from within, they stretch farther than we could ever hope to travel in a human lifetime, farther than we can currently imagine reaching. There is a strange, melancholy beauty in knowing that the solar system, our cosmic home, is not a neat, orderly line of planets, but a sprawling, uneven, chaotic system of worlds, asteroid belts, and icy clouds. The outer reaches remind us that edges are rarely sharp in space. They are fuzzy. They fade. They slowly blend into the next scale of magnitude. Just as the solar system gradually blends into the galaxy, the Kuiper Belt and the Oort Cloud blend into the cold medium of interstellar space. Leaving our system is less like stepping decisively across a painted line, and much more like walking into a thick mist that gradually, imperceptibly becomes an entirely different landscape. Beyond the Oort Cloud, the familiar sense of home begins to completely dissolve. Up until this point in our journey, we have still been speaking of the solar system, even if we were looking at its widest, most distant, most alien form. The Kuiper Belt, the scattered icy bodies, the trillions of frozen remnants that might make up the Oort Cloud, all of these things are still under the faint, lingering pull of the sun. They are family. However distant, however forgotten in the dark, they belong to us. But past that final, invisible shell, the grip of our star begins to loosen and fail. The sun's light grows dimmer and dimmer until it is absolutely no brighter than the countless other stars scattered across the sky. The warmth is entirely gone. The solar wind no longer dominates the space around you, And at some undefined point, after crossing a distance so great it is almost meaningless to assign a number to it, you finally step beyond the boundary where our solar system ends and the galaxy itself truly begins. This new region is not well mapped. It is not filled with dramatic, swirling features or glowing, colourful landmarks. Instead, it is mostly characterized by a crushing, absolute emptiness. Between the stars, the distances are so unfathomably large that even a word like vast feels entirely inadequate and small. The nearest star to our Sun, Proxima Centauri, lies more than 4 light-years away. That means, if you left the Earth right now and aimed yourself directly toward it, you would still cross through 4 entire years of light's journey in unbroken darkness before you arrived. Light covers nearly 10 trillion kilometers every single year. Multiply that staggering number by 4, and you get a gap so enormous, a void so wide, that it hardly seems real to the human mind. This terrifying gulf is exactly what lies beyond the Oort Cloud, forming the silent, freezing realm between the stars. Space out here is not entirely, perfectly empty. It contains a thin, whispering gas, mostly hydrogen, made of drifting atoms, left over from the violent birth of the galaxy. It contains microscopic dust, tiny, ancient grains that can scatter light and sometimes gather together into denser, darker clouds. It contains twisting magnetic fields and high-energy cosmic rays, subatomic particles that have wandered through the void for millions of years. But to our human senses, if we were floating out there without a ship, it would feel like absolute nothingness. The density of matter in interstellar space is so incredibly low that if you scooped up a cubic centimeter of it, it might hold only a single, solitary atom. Compare that to the air you are breathing right now, which contains billions of rapidly moving molecules in that exact same amount of space, and you begin to see just how terrifyingly empty the galactic void truly is. And yet, this near nothingness is the essential backdrop for absolutely everything. It is the canvas upon which the universe paints its greatest masterpieces. Stars are born in the denser, colder pockets of this interstellar medium. Nebulae, those glowing, colourful clouds we see in spectacular telescope photographs, are the cosmic nurseries where gravity patiently pulls these sparse atoms together, compressing them over millions of years until nuclear fusion finally ignites. In other regions of this dark sea, dying stars explode as violent supernovae, scattering heavy, complex elements, carbon, oxygen, iron out into the thin gas around them. Over unimaginable stretches of time, those newly forged elements drift through the void, eventually becoming part of new stars, new rocky planets, and perhaps new forms of life. So, while the space between the stars feels like a dead and empty wasteland, it is actually the great, churning cycle from which entire galaxies renew themselves. If you picture yourself leaving the outer edge of the Oort Cloud and drifting freely into this interstellar space, the sun would slowly, inevitably, fade behind you. At first, it would still be the brightest object in your sky, a brilliant diamond holding your gaze. But gradually, as you moved farther and farther into the deep, it would shrink until it looked exactly like any other star. You would not even know which one was yours unless you carried a star map to guide you. And surrounding you, in every possible direction, would be thousands upon thousands of other piercing points of light, each one a massive, burning star, each one its own complex system, with its own planets, its own moons, and perhaps its own quiet stories of life. The profound, crushing loneliness of interstellar space is softly tempered by the beautiful knowledge that every single dot of light is another sun, another potential home in the dark. But the distance to the next star is not just a large number, it is a physical, existential limit. Our fastest spacecraft, the Voyagers, moving at over 60,000 kilometers per hour, would take tens of thousands of years to reach even the nearest neighboring star. Tens of thousands of years is a span of time longer than all of recorded human history. It means that, in practical, physical terms, the stars are completely unreachable to us with our current technology. The gulf beyond the Oort Cloud is not just a physical barrier, but an existential one. It constantly reminds us of the sheer scale of separation that is built into the very architecture of the galaxy. And yet, the stars still manage to speak across that terrifying distance. Their light reaches us, crossing the void to land in our eyes. Radio waves, whether natural or artificially created, travel in the exact same way. In theory, if another intelligent civilization exists around a nearby star, their signals could cross this dark ocean just as easily as ours can. The distances are immense, but they do not enforce absolute silence. They only enforce a delay. A message sent from Proxima Centauri would take 4 long years to arrive at our radio dishes. A message from a star 20 light-years away would take 20 years to reach our ears. A conversation across interstellar space would be agonizingly slow, a dialogue spanning generations, but it would not be impossible. That tantalizing possibility has long stirred human imaginations, because it reminds us that the cosmic gulf is not absolute. It is a formidable barrier, yes, but it is one that light and information can cross. Drifting in this realm beyond the Oort Cloud also brings a profound shift in perspective. Within the bounds of the solar system, the sun is always the absolute center of everything. Every planetary orbit, every comet's trajectory, every measurement we take refers back to that central burning anchor. But once you are untethered, floating out here between the stars, there is no clear center anymore. The galaxy stretches around you in all directions, a dizzying, flattened disk made of hundreds of billions of stars. You are no longer inside a system. You are floating in a sea. The comforting sense of belonging to one specific star slowly fades away, and you begin to feel, instead, like a tiny part of the much larger, grander collection. For the very first time in your journey, the solar system is no longer the framework of your reality. The galaxy is. Astronomers often describe this interstellar space as a harsh, unforgiving environment, filled with dangerous radiation and temperatures far colder than any place near a star. Yet, it is also deeply serene in its incomprehensible scale. Imagine floating in that perfect darkness, completely surrounded by stars. There is no up, there is no down, there is only a beautiful random scattering of points across infinity. The silence is complete. The emptiness is almost perfect. But in that emptiness, the entire history of the galaxy is written. Every single atom drifting through that void may have once been part of a burning star, a shattered planet, or even a living being. Over billions of years, matter circulates through this dark sea, broken apart, reassembled, and reformed in a never-ending cosmic dance. By stepping beyond the Oort Cloud, you are not simply leaving something behind. You are entering the wider, eternal cycle of the universe. Sometimes, when astronomers speak of this specific patch of the galaxy, they use the term local bubble, referring to a massive, invisible cavity carved out of the interstellar medium by the violent explosions of ancient supernovae, a hollowed-out region of space that we currently happen to be drifting through as we prepare to finally look upon the faces of our closest stellar neighbours. We reside deep within this pocket of lower-density gas, a vast and quiet chamber shaped long ago by the death cries of massive dying stars. Beyond the icy boundaries of the Oort Cloud, you are not merely floating in empty space. You are wading through the residual history of ancient explosions, stellar births, and galactic collisions that built the Milky Way. Our sun itself was not born in isolation. It ignited alongside a cluster of sibling stars, a fiery nursery of newborn light, but over billions of years those siblings drifted away, scattered by the gravitational tides of the galaxy. Somewhere out there, hidden among the billions, they still shine. The gulf between these stars may feel unimaginably uncrossable, but on the scale of the galaxy, it is simply the basic unit of measurement. Just as the gap between planets defines the architecture of the solar system, the yawning gap between stars defines the architecture of the galaxy. Each step outward adds another daunting layer of distance, stretching the measure until it no longer fits within ordinary thought. But that is the fundamental rhythm of the universe, always larger, always farther, always stretching the boundaries of human imagination. When you stand on Earth and look up at the night sky, you are already seeing far beyond the distant, frozen shell of the Oort Cloud. You are looking directly into the depths of interstellar space, a realm overflowing with stars. Every constellation you can name, every faint twinkle that catches your eye, every delicate band of light stretching across the dark is an integral part of this cosmic ocean. It is not a place you must visit by travelling outward in a ship. It is a place you see every clear night without ever leaving the comfort of your home. The only difference is that you are standing inside the solar system, looking out through the window of our atmosphere. To actually be out there, floating in the void between the stars, would be to live inside the view itself. When you finally step far enough beyond the fading, invisible influence of the sun, the other stars around us begin to take on a much more profound presence. From the surface of Earth they appear as mere pinpricks in the night sky, tiny fragile points of light that twinkle and dance because of the shifting currents of our atmosphere. But out here, in the absolute vacuum where there is no air to blur or scatter their glow, they would shine as fierce, steady beacons. And though each one looks incredibly small from a distance, each is a sun, enormous and burning with its own immense gravity, its own complex planetary system, and its own ancient story. Meeting our stellar neighbours means truly seeing that we are not alone in this vast sea of light. The very closest of these neighbours is Proxima Centauri, a small, unassuming red dwarf star located just over 4 light-years away. It is so incredibly faint that you cannot see it with the naked eye from Earth, even on the darkest, clearest night far from any city lights. Yet, it sits closer to us than any other star in the universe, save for our own sun. Proxima is a humbling reminder that the vast majority of stars in the galaxy are not grand, blindingly bright giants, but small, dim, and quiet ones. Red dwarfs like Proxima burn their nuclear fuel incredibly slowly, with lifetimes measured not in mere billions, but in trillions of years. If the universe lasts long enough, these unassuming red dwarfs will be the final stars still shining in the dark, long after all the larger, more boastful suns have burned out and faded away. And even this tiny, dim neighbour possesses worlds of its own. Astronomers have detected at least 2 planets orbiting Proxima Centauri, and one of them traces its path squarely within the habitable zone, the delicate region where liquid water could theoretically exist on its surface. Whether that world is barren rock or teeming with alien life, we do not yet know, but its very presence in the dark suggests a profound truth. Planets are not rare, even around the smallest and dimmest of suns. Nearby, locked within the exact same star system, are Alpha Centauri A and B, 2 stars bound together in a perpetual gravitational orbit. Unlike Proxima, these are bright, sun-like stars, easily visible from Earth's southern hemisphere as a brilliant pair of points. They sit closer to each other than Earth is to Saturn, endlessly circling one another in an intricate, cosmic dance. For centuries, People have looked up at that light and wondered what kinds of worlds might orbit them. Imagine, for a moment, standing on the surface of a planet there, looking up to see two suns hanging in the alien sky, one slightly larger, one slightly smaller, casting overlapping dual shadows across the landscape and painting the horizon with breathtaking double sunsets. If such a world truly exists, it would feel both profoundly alien and strangely, hauntingly familiar at the exact same time. The rhythm of days would be complex, and the warmth of two stars might drive the shifting of seasons in ways we cannot yet begin to imagine. Beyond the Alpha Centauri system, the list of our stellar neighbours expands quickly, introducing a cast of deeply diverse characters. There is Barnard's star, a faint red dwarf roughly 6 light-years away, which moves rapidly across our sky compared to the more distant background stars. Wolf 359, another dim and quiet dwarf, lies not much farther into the dark. Then there is Sirius, the brightest star in our entire night sky, sitting a mere 8 light-years distant. It outshines almost every other neighbour in our vicinity because it is both incredibly large and relatively close. To the naked human eye, Sirius looks like a single, piercing point of brilliant blue-white light, but it is actually a binary system, featuring a massive main star paired with a faint, incredibly dense white dwarf companion. That white dwarf is the burned-out, exhausted remnant of a star that once shone brightly, long before human eyes existed to see it. It has now collapsed into a dense, superheated core roughly the size of Earth, but packing the gravitational mass of an entire sun. To imagine such an extreme object lurking nearby is to see both the distant future and the ancient past of stars contained within a single, fascinating system. Each of these neighbours lies only a few light-years away, but that phrase is a masterful deception of cosmic scale. 4 light-years is 40 trillion kilometres, 6 light-years is 60 trillion. These are distances so unfathomably large that even beams of light, travelling at the absolute speed limit of the universe, take years to bridge the silent gaps between them. Yet, on the grand scale of the galaxy, they are remarkably close. If the Milky Way were shrunk down to the size of a sprawling city, these nearby stars would be the houses sitting directly on your street. The next cluster of stars would be a neighbourhood across town, and the far edges of the galaxy would be whole continents away. What makes meeting these neighbours so striking is the sheer diversity among them. Some are hot, violent blue giants, radiating so much intense energy that they will live for only a few million years before detonating in spectacular supernovae. Others are tiny, glowing faintly and patiently for trillions of years. Some wander alone through the dark, while others are locked into binary or even triple systems, endlessly spinning around a shared centre of gravity. And circling these diverse stars are the exoplanets. Astronomers have only recently begun to glimpse these hidden worlds, using incredibly careful measurements of starlight to detect the subtle, gravitational wobble caused by an orbiting planet, or the tiny, rhythmic dimming of light when a world passes directly in front of its host star. Already, thousands of exoplanets have been found, and among the nearest stars, planets are proving to be astonishingly common. There are gas giants far larger than Jupiter, small rocky worlds similar to Earth, massive super-Earths several times our size, and strange, exotic worlds unlike anything in our own solar system. There are hot Jupiters whirling dangerously close to their suns, and frozen giants orbiting in the lonely, frigid dark far away. Meeting our stellar neighbours is not just about the stars themselves, but about the intricate planetary systems they carry with them through the void. Imagine if you could visit one of them, perhaps a rocky world orbiting Proxima Centauri. You would stand on its surface under the dim, eternal red glow of its star. The light would be much weaker than our sunlight, tinting the entire landscape in deep crimson shadows. days and nights might not even exist in the way we understand them, because many planets around red dwarfs orbit so close to their stars that they become tidally locked. One side of the planet permanently faces the star, baking in eternal daylight, while the other side faces the infinite void, frozen in eternal pitch-black night. Life, if it somehow exists there, might cluster in the narrow twilight zones, the perpetual ring of sunset where the light is neither too punishingly strong nor entirely absent. These possibilities stir not only our scientific curiosity, but a deep, resonant sense of connection. When you realize that even our nearest stellar neighbors possess planets, the idea that life could exist elsewhere begins to feel less like wild speculation and much more like statistical probability. If the nearest stars have them, and the next stars too, and the next, then across hundreds of billions of suns, the chances grow overwhelmingly large. Meeting our stellar neighbors, even if only in thought, is also meeting the profound possibility of other lives, other histories, other minds looking back at the dark. But even if no life exists out there, the stars themselves are worth knowing. Sirius, shining blue-white and dazzling on crisp winter nights. Procyon, another bright anchor in the same cosmic neighborhood. Epsilon Eridani, a young, restless star surrounded by chaotic dust rings and tantalizing hints of forming planets, located just 10 light-years away. Each one is close enough that we can easily imagine visiting them, close enough that their light is still relatively young when it finally reaches our eyes. The photons that strike your retina from Proxima Centauri began their journey across the void just 4 years ago. From Sirius, 8 years ago. From Epsilon Eridani, 10. These spans of time are vanishingly small compared to the ancient age of the universe. They remind us that, in galactic terms, our neighbors are near enough for their luminous stories to reach us almost immediately. This diversity gives us a profound sense of the galaxy's richness. Our Sun is an ordinary star, mid-sized and mid-aged, a quiet resident of the galactic suburbs. Yet, among our immediate neighbors are the crushed remnants of old, dead stars, newborns just beginning to ignite their nuclear fires, pairs circling one another in gravitational embraces, and giants that burn hot and fast. To meet them is to see that even our local neighborhood holds every single stage of stellar life, a complete cosmic ecosystem right outside our door. And just as our solar system has its outer reaches, each of these stars may be surrounded by their own unseen belts, icy clouds, or wandering objects. The neighborhood is not empty. It is full of suns, each with its own gravitational reach, its own territory in the dark. If you could somehow transport yourself to a vantage point halfway between our Sun and Proxima Centauri and look around, the sky would look drastically different. The constellations we know so well would shift, their familiar, mythological shapes stretched and bent by the sudden change in perspective. Orion, for instance, would no longer look like the great hunter we recognize from Earth. Some stars would have shifted their positions noticeably, breaking the ancient patterns. Constellations, you see, are merely patterns seen from our specific vantage point on Earth, but they are not fixed, physical structures. They are the product of our viewpoint, optical illusions created by the alignment of near and distant stars. To stand among the stars is to see that their arrangements are illusions of distance, changing and morphing with every step you take outward into the void. And beyond even these close neighbors, more stars wait in the silence. Each step outward multiplies the number of suns until the sky becomes a dense, blinding scattering of light. The local neighborhood extends for dozens of light years, a region filled with hundreds of unique stars. Some are brighter, some dimmer, but altogether they form the tiny patch of the galaxy we can proudly call our own. Meeting them is only the very beginning of seeing the Milky Way as a whole. So, as we drift further outward, past the fading, ghostly influence of the sun, past the emptiness between, and into the crowded company of these other stars, we begin to understand the scale differently. We are not just one solar system floating in total isolation. We are part of a vibrant stellar community. Each neighbor is close enough to touch us with its light, reminding us that the galaxy is not an abstract concept, but a real, crowded place, filled to the brim with burning suns. When you look up at the night sky from a truly dark place, far away from the blinding glare of city lights, you might notice a faint ghostly band stretching across the heavens. It looks exactly like spilled milk, hazy and incredibly delicate, broken in places by darker, shadowy lanes where thick cosmic dust hides the glow behind it. For thousands of years, people have looked up at this band and given it names: a celestial river, a pathway for the gods, the glowing spine of the night. Today, we call it the Milky Way. And what you see in that faint, ethereal band is not mist or cloud or atmospheric illusion, but the combined, blended light of billions upon billions of distant stars. Each one is too far and too incredibly faint to be seen alone, but together they merge into a soft, unbroken glow that spans the entire sky. That streak of light is our first direct, visceral glimpse of the true shape of the galaxy we live in. At first, it seems strange, almost counterintuitive, to think we can know the galaxy's overall form when we are trapped deep inside it. Imagine trying to see the overall shape of an immense forest while standing right in the middle of the trees. From the ground, you cannot see the full pattern or the outer boundaries. You only see tree trunks rising around you in every direction. But if you study carefully the density of the trees in each direction, the way the shadows fall, the precise distances between the clearings, you can begin to infer the forest's grand outline. Astronomers did much the same thing with the night sky. They meticulously mapped the positions of stars, counted them, measured their subtle motions, and slowly realized that our galaxy has a very specific, elegant structure. It is not a random, chaotic scatter of stars. It is a disk, incredibly broad and impossibly thin, with majestic arms spiraling outward, all rotating slowly around a bright, densely packed central bulge of stars. The Milky Way is vast, beyond the limits of simple numbers. Its diameter is about 100,000 light-years across. If you could somehow ride a beam of light from one edge to the exact opposite side, it would take you 100,000 years to cross the galactic sea. Its thickness, however, is only about 1,000 light-years, making it proportionately like a pancake spread incredibly thin, with a central bulge that swells upward and downward in the middle. Within this sprawling disk are hundreds of billions of stars, along with vast oceans of gas, swirling dust, and the invisible, ghostly presence of dark matter. We cannot see the dark matter directly, but we know it must be there from the way its immense gravity pulls on the stars we can see. The spiral arms are perhaps the galaxy's most beautiful and dynamic feature. They are not rigid, solid structures like the spokes of a wheel. They are regions of higher density, cosmic waves moving gracefully through the disk where stars temporarily become more concentrated. As massive gas clouds drift into these slow-moving arms, they are violently compressed, triggering magnificent new bursts of star formation. That is precisely why the spiral arms glow so fiercely with young, hot blue stars, and with the vibrant pink hues of glowing hydrogen nebulae. Between the arms, the stars are older, dimmer, and far fewer in number. The pattern is not fixed, but fluid and dynamic, slowly changing and morphing over millions of years. Still, if you could view it from afar, It would look like a graceful, luminous spiral, a glowing pinwheel turning silently in the absolute dark. We cannot step outside our galaxy to see this directly. Every stunning image you have ever seen of a spiral galaxy from above is a photograph of another galaxy entirely, not our own. But by studying those distant galaxies, and by painstakingly measuring the stars immediately around us, we have slowly pieced together a breathtaking portrait of what our cosmic home must look like, leaving us to wonder what magnificent secrets lie hidden at the very core of this spinning wheel of light. We live not in the chaotic, crowded center of this magnificent structure, but out in one of the quieter spiral arms. This local neighborhood, a smaller offshoot known as the Orion Arm, is located about halfway between the blinding galactic core and the fading outer edge. That is our precise address on the grand galactic scale. We are not positioned at the bustling hub, nor are we clinging to the absolute rim. We rest comfortably in between, drifting through a region where the spaces between stars are vast enough to offer safety, yet close enough to provide a sky filled with gentle, distant light. If you were to travel inward from our quiet suburb, the environment would change dramatically. The central bulge of the Milky Way is a dense, intensely crowded region, absolutely overflowing with ancient stars. They are packed so tightly that if we lived on a planet near the core, the night sky would blaze with the light of 1,000,000 suns, erasing the darkness entirely. But at the very heart of this radiant bulge lies something even stranger, something completely invisible. A supermassive black hole, millions of times the mass of our own sun, sits silently at the absolute center. It is known as Sagittarius A star, hidden entirely behind thick, impenetrable clouds of interstellar dust. We cannot see it with our eyes, nor can optical telescopes pierce the veil. Yet, radio telescopes have patiently traced its overwhelming gravitational presence. By watching the stars closest to the core, astronomers realized that these ancient suns were whipping around an invisible point at incredible, terrifying speeds. They are moving so fast that only a mass of incomprehensible density could keep them from flying off into the void. That black hole anchors the entire galaxy. It holds the orbits of billions of stars in a delicate, eternal balance, though it does not pull them all in like a drain. Instead, it serves as the gravitational focal point, the heavy heart around which the entire Milky Way slowly, majestically turns. If you could somehow achieve an impossible vantage point, hovering millions of light years above the galactic plane, the view would leave you breathless. You would see the flat, shimmering disk of stars, the glowing arms curling outward like ribbons of fire, the intensely bright center, and the faint, ghostly halos of older stars surrounding it all. But even this breathtaking vision would be incomplete. Beyond all the visible light, beyond the glowing gas and the shining suns, there is a massive, invisible envelope known as the dark matter halo. This halo extends far, far beyond the outermost stars we can see. It is completely unseen, yet without it, the rotation of the galaxy would make absolutely no sense. The stars at the very edges of the Milky Way move much faster than the laws of physics say they should if only the visible matter existed. There is simply not enough glowing mass to keep them tethered. Dark matter provides the missing gravity, the unseen glue holding the spinning wheel together, though what it actually is remains one of the deepest, most profound mysteries in all of science. Because we are trapped inside the disk, looking out from our vantage point within the Orion Arm, we see our galaxy entirely edge on. That is exactly why the Milky Way appears to us as a singular glowing band stretching across the night sky. We are looking directly along the flat plane of the disk, our gaze passing through layer upon layer of stars, gas, and obscuring dust. When we look in directions away from that glowing band, we are looking up or down, out of the thin disk and into the vast, empty regions where far fewer stars lie. This simple geometry explains why our night sky possesses the structure it does, appearing heavily crowded in one specific direction and starkly sparse in all others. Every single night you have ever looked up and noticed that pale river of light, you have been witnessing direct, undeniable evidence of the galaxy's true shape, perhaps without even realizing it. To truly appreciate the sheer size of this structure, we must return to the concept of light years. We spoke of our nearest stellar neighbours as being a handful of light years away, a distance that already breaks the human mind. The entire galaxy, however, spans 100,000 light years across. That means there are not merely a few stars nearby, but hundreds of billions of them, stretching infinitely in every conceivable direction. There are so many suns that even with the most advanced, powerful telescopes humanity has ever constructed, we can never hope to see them all individually. They merge into a continuous soft background glow, much the same way the distant, scattered streetlights of a sprawling city blur together into a hazy, glowing dome on the horizon. Our particular place in this colossal city of stars is both entirely ordinary and completely extraordinary. It is ordinary because there is nothing particularly unique or special about our sun. It is a mid-sized, middle-aged star drifting in a mid-sized spiral arm, neither near the centre nor on the edge. Yet, it is extraordinary because this seemingly mundane position grants us an incredibly stable environment. We are far removed from the violent chaos of the crowded core, where frequent supernovas and wandering black holes would bathe planets in lethal radiation, making the delicate evolution of life virtually impossible. From this quiet, undisturbed suburb of the Milky Way, life on Earth has been allowed to flourish, uninterrupted, for billions of years. But this quiet suburb is not entirely at rest. The galaxy is not a static, frozen painting. It is alive with motion, rotating slowly, deliberately, taking about 200 million years for our sun to complete just one single orbit around the galactic center. This means that since the Earth first coalesced from a cloud of dust 4.5 billion years ago, our solar system has circled the entire galaxy more than 20 times. With every grand orbit, the sky above our world would have looked slightly, imperceptibly different. As the eons passed, the stars immediately around us shifted their positions. Glowing spiral arms approached and slowly passed us by, and vast, dark clouds of interstellar gas drifted through our path. The galaxy is a living, breathing entity, constantly in motion, even if that motion unfolds on time scales far too long for a human life to ever notice. When we met our stellar neighbours, we were given a brief, tantalizing glimpse of the incredible diversity of stars that exist nearby. Seeing the overall shape of the galaxy now provides us with the ultimate context for all of them. These stars are not scattered randomly or haphazardly through the void. They are arranged in a grand, sweeping structure, a magnificent spiral defined by a pattern of density waves and flowing, graceful motion. And this mesmerizing pattern is only one among countless others scattered across the dark. Every spiral galaxy you ever see through the lens of a telescope is another city of stars just like ours, another glowing wheel turning silently in the deep night. If you could hover outside and look back at the Milky Way, you would be struck not just by its breathtaking beauty, but by its crushing, overwhelming scale. You would see that our entire solar system is nothing more than one tiny microscopic dot in one of the sweeping arms, completely indistinguishable from the billions of others. You would suddenly realize that all the triumphs and tragedies of Earth, all of human history, all the lives ever lived, are unfolding on a nearly invisible speck suspended within this vast, turning disk. And yet, that tiny speck is an integral part of something immense, something profoundly luminous, something intimately woven into the much larger fabric of the cosmos. From this elevated perspective, it becomes entirely natural to wonder exactly how many stars are actually out there, how many lights fill this spinning disk, how many suns lie waiting in the dark, each with their own orbiting worlds, their own unique possibilities. When you walk outside on a crisp night, look up at the sky, and see a brilliant scattering of stars, it is incredibly tempting to imagine that what you are seeing represents a significant portion of what is truly there. But in reality, your eyes are only catching the absolute tiniest, most microscopic fraction of the galaxy's population. On the very best, clearest night, standing far away from the interference of city lights, your unaided eyes might be able to pick out a few thousand stars. That number sounds relatively large until you compare it to the true hidden population of the Milky Way, which is estimated to hold hundreds of billions of suns. The sheer gap between what we can see from our backyards and what is actually out there in the dark is almost beyond belief. Counting the stars of the Milky Way is not simply a matter of tallying them up, one by one, like coins dropped into a glass jar. It is a profound exercise in measurement, mathematical inference, and human imagination, because the truth is, no one will ever count them one by one. Astronomers have long tried to estimate the true number using a clever mix of careful observation and logical reasoning. One method is to measure the total gravitational mass of the entire galaxy, and then estimate exactly how much of that immense mass belongs strictly to stars, as opposed to the swirling gas, the dust, and the invisible dark matter. By dividing that estimated stellar mass by the average mass of a single star, you arrive at a rough, overarching count. Another method involves meticulously counting the individual stars in a very small, well-defined patch of the galaxy, a region where telescopes can observe them more directly, and then scaling that number up based on the total physical size of the Milky Way as a whole. Neither of these methods is absolutely perfect, but both remarkably converge on the same staggering idea. The Milky Way contains somewhere between 100 billion and 400 billion individual stars. That massive range alone, a margin of error of 300 billion, tells you exactly how difficult this number is to pin down. Even with all our miraculous modern technology, we can only narrow the population down to within hundreds of billions. But let us pause for a moment and truly think about what the word billion actually means. In everyday life, a billion is a number we hear frequently, but we rarely grasp its true weight. 1,000 seconds is a little less than 17 minutes. A million seconds is about 11.5 days. But a billion seconds? That is over 31 years. When we casually talk about 100 billion stars, we are talking about a number so fundamentally large that even breaking it down into years of seconds still feels completely overwhelming. It is the kind of number that slips effortlessly out of the fingers of human comprehension, and yet we can try to build a fragile sense of it through earthly comparisons. Imagine once again that every single star in the galaxy were a tiny grain of sand. 100 billion grains of sand would completely fill several massive sports stadiums to the brim. 400 billion grains would cover entire coastal beaches. Or, picture the stars as people. The entire human population of Earth is roughly 8 billion. The Milky Way holds 10 to 50 times that many suns. If every single human being currently alive represented a star, you would need several dozen entire Earths just to match the population of our single galaxy. Suddenly, the sky above you feels far less like a scattered empty field and much more like a bustling, impossibly crowded metropolis, overflowing with brilliant lights. Of course, not all of these stars are the same. The galaxy is a diverse, thriving ecosystem. Some are massive blue giants, many times the mass of our sun, burning with an intense, furious brightness, but living incredibly brief lives before detonating. Others are small, dim dwarfs, slowly and efficiently burning their fuel for trillions of years. In fact, the vast majority of the stars in the galaxy are not like our Sun at all. They are significantly smaller, much cooler, and cast a deep red light. These red dwarfs make up perhaps 3/4 of the entire Milky Way's population. They are incredibly faint. They are so faint, in fact, that not a single red dwarf is visible to the naked human eye from Earth, even though they heavily surround us in absolutely every direction. That means that when you look up at the night sky, you are not actually seeing the majority of the galaxy's inhabitants. You are seeing only the brighter exceptions, the rare, highly luminous few that shine strongly enough to cross the vast gulf of space and be noticed from Earth without the aid of a telescope. The true, overwhelming count of the galaxy is entirely hidden from you, woven silently into the dark. And then there are the fascinating extremes. There are white dwarfs, the slowly cooling, burned-out cores of ancient stars that have completely finished their active lives. There are neutron stars, collapsed remnants so terrifyingly dense that a single teaspoon of their matter would outweigh a towering mountain on Earth. There are the black holes, completely invisible, yet still actively counted in the grand tally of stellar remnants. All of these strange, beautiful objects are part of the Milky Way's incredibly diverse population. Counting the stars means counting not only those that burn brightly today, but also honoring those that once did, and anticipating those that will ignite in the distant future. To add yet another complex layer to this cosmic census, many of these stars do not wander the dark alone. Roughly half of all the stars in the sky belong to binary or multiple star systems pairs or trios of suns locked in a gravitational embrace, orbiting endlessly around each other. To our eyes, they may look like a single, solitary point of light piercing the night, but up close, they are intimate families. Some circle each other so closely that they constantly trade swirling streams of gas and intense energy. Others are separated by incredibly great distances, drifting together through their long orbits like distant, quiet companions. Counting the stars is not only about tallying up lone individuals, but about recognizing these intricate systems as vital parts of the greater whole. Furthermore, the sheer number of stars gives us a breathtaking sense of exactly how many planets may exist out there in the dark. With the revolutionary discovery of exoplanets, we now know with certainty that planets are incredibly common. Almost every single star likely hosts at least one orbiting world. Many host entire complex systems of several planets. If the Milky Way holds hundreds of billions of stars, then it inevitably holds hundreds of billions of planets, perhaps even stretching into the trillions. Some of these unseen worlds are rocky and barren. Some are vast oceans of swirling gas, some are locked in permanent ice, and some are scorching hot. The sheer, unadulterated abundance of these worlds is staggering. The night sky is not just filled with burning suns, but with countless hidden worlds, the vast majority of which we will never be able to see directly. The true underlying richness of the galaxy lies not only in its brilliant stars, but in the infinite possibilities of the countless systems orbiting them. When you think deeply about trying to count the stars, you realize very quickly that the task is not only about managing unfathomable numbers, but about understanding the uneven nature of cosmic scale. Imagine dividing the entire galaxy into three-dimensional patches, each one a perfectly square light-year across. In our quiet local neighborhood, there are only a small handful of stars drifting within that vast volume of space. But as you move closer to the galactic center, the density rises dramatically. There, stars crowd together much more tightly, separated by only tiny fractions of a light year, bathing their planets in perpetual, blinding daylight. In globular clusters, those ancient, spherical groups of stars orbiting the outer edges of the Milky Way, the density is even greater, with thousands of suns packed tightly into incredibly small volumes of space. Counting the stars means recognizing that they are not evenly spread out like a fine mist, but dynamically gathered and thinned, incredibly dense in some places and hauntingly sparse in others. And then there is the galactic halo, the faint, ghostly population of stars orbiting far above and far below the main disk. These halo stars are far older, much dimmer, and incredibly hard to see. But they too belong to the final count. They serve as a quiet reminder that the galaxy is not merely a flat disk, but a massive, three-dimensional structure filled with hidden layers, ancient components, and forgotten histories. What does it truly mean to know, deep in your bones, that there are hundreds of billions of stars in the Milky Way? For one thing, it completely changes how we view ourselves in the grand scheme of things. Here on Earth, we naturally tend to think of our sun as central and dominant. It commands our daytime sky, dictates our seasons, fuels our lives, and anchors our entire planetary system. But when placed in the true context of the wider galaxy, our sun is just one single flickering light among hundreds of billions. It is entirely unremarkable, except for the profound fact that we happen to live near it. It is merely one grain of sand on a vast, seemingly endless beach, one faint light among countless others. This perspective can feel deeply humbling, stripping away our illusions of cosmic importance, but it can also feel strangely reassuring. The exact same fundamental laws of physics that govern the slow burning of our sun govern every single one of them. The exact same natural processes that form the Earth's rocky crust and deep oceans are happening right now, everywhere across the dark. We are not separate from the galaxy, isolated in a void. We are an ordinary, intrinsic part of its fabric. And yet, being ordinary does not mean we are of small insignificance, because to us, this single, solitary star is absolutely everything. It is the anchor of our existence, the ultimate source of all our energy, the beating heart of our local system. In the middle of an unimaginably vast crowd, it is the one light that matters most to our survival. That delicate tension between being just one of billions and being absolutely everything to ourselves is part of the profound wonder of attempting to count the stars. Because if you look closely enough at the numbers, you begin to realize that each one of those distant points of light is someone else's sun, holding the potential for its own worlds, its own histories, and its own quiet observers looking back across the dark, wondering exactly the same things we do. When astronomers carefully attempt to count these stars and map the potential homes of these distant observers, they are not simply tallying numbers on a cold cosmic ledger. They are piecing together a vast timeline, reconstructing a deeply intricate story of how the Milky Way itself was formed and how it continues to evolve. The oldest stars in our galaxy, which are notably scarce in heavy elements, date back to the very dawn of the universe, to a quiet, ancient time when only hydrogen and helium drifted through the expanding void. Younger stars, by striking contrast, are heavily laced with complex metals forged in the fiery, violent deaths of ancient supernovae, their rich remnants scattered widely across the galactic plane over eons. This intricate, layered mix of ages tells us that the Milky Way is not a static, silent museum of celestial objects, but a thriving, breathing city of light that has been forming new suns for billions of years and continues to do so in the dark. Yet, even with all our advanced instruments and collective knowledge, the exact number of these stars remains beautifully approximate. A perfectly precise number might somehow reduce the profound sense of immensity that washes over us when we look up. To simply know that there are hundreds of billions of them, that they fill the sweeping disk and the glowing halo, that they stretch endlessly from the dense, chaotic center to the quiet, fading edge, is more than enough to remind us of the staggering vastness of the place we call home. When you next step outside on a clear night and look up, remember that each star you see is only one out of hundreds of billions, and that the vast majority of the stars in our galaxy remain entirely invisible to your naked eyes. The galaxy is not merely a random scattering of points against a black canvas, but an ocean of light so unimaginably vast that our human senses can only catch a tiny, shimmering spray from its cosmic wave. When we talk about the Milky Way, it is incredibly easy to focus our attention on the stars alone. After all, they are the objects that shine. They are the brilliant beacons you see when you glance upward on a crisp, quiet night. But stars are by no means the only inhabitants of our galaxy. Between them, orbiting around them, and lingering long after they have died, exist other objects, phenomena far stranger and sometimes far more beautiful than we might ever expect. Black holes, nebulae, dense star clusters, and ghostly remnants, these fill the galaxy with an astonishing, rich variety. They serve as quiet reminders that the Milky Way is not only a crowded city of stars, but a sprawling, dynamic landscape of absolute wonders. Black holes, for instance, are among the most mysterious and captivating residents of this deep landscape. They are born from the violent, catastrophic collapse of massive stars, stars that are many times heavier and more furious than our own Sun. When such a colossal star finally burns through its nuclear fuel, its core can no longer support the crushing, inward weight of its own outer layers. Gravity, the silent and relentless architect of the cosmos, takes over entirely, crushing the core inward with such ferocity that absolutely nothing can resist its pull. The terrifying result is a point in space so incredibly dense, so profoundly curved in its space-time, that not even light, the absolute fastest traveller in the universe, can escape its grasp. That is the black hole, invisible by its very nature, yet dramatically revealed by its powerful, distorting effects on the world around it. Our galaxy is thought to contain millions of these stellar mass black holes, scattered quietly, almost stealthily, through the galactic disk. Most of them are entirely dark and hidden, drifting in absolute silence, giving themselves away only when a companion star happens to stray just a little too close to their invisible boundary. In such fateful cases, gas from the companion is violently stripped away, spiraling inward to form a highly energized disk, heating up to unimaginable temperatures and glowing fiercely with X-rays before vanishing forever beyond the event horizon. From our safe vantage point here on Earth, astronomers detect these sudden X-ray flashes, these sudden beacons flaring in the absolute dark, as undeniable evidence of a black hole actively feeding. They are not malicious monsters hunting down innocent stars, but rather the natural, inevitable remnants of massive stars that lived out their furious lives and died long ago, continuing the grand cosmic cycle in a vastly different, invisible form. Yet, at the very centre of the Milky Way lies something far larger, a gravitational titan known as Sagittarius A star. This is a supermassive black hole, possessing millions of times the mass of our Sun, sitting quietly at the very core of our galactic home. For decades, its shadowy presence was deeply suspected, inferred from the frantic, looping motions of the objects around it. But only in recent years has its immense gravity been measured directly and visually confirmed. Astronomers watched in awe as stars near the galactic centre whipped around something entirely invisible, moving at thousands of kilometers per second in desperate, elliptical orbits. Only a mass so intensely concentrated, so impossibly compact, could explain such violent, high-speed trajectories. And then, in the year 2022, the Event Horizon Telescope collaboration released the very first image of Sagittarius A star, a faint, glowing ring of bent light surrounding a deep, dark shadow finally confirming what mathematical theory had long predicted. That image was not a photograph in the everyday sense, but a painstakingly complex reconstruction of radio waves collected by observatories scattered across our entire planet, stitched together to reveal the very shape of the unseeable. To know that such an overwhelming, reality-bending entity exists right at the core of our home galaxy is a thought that is both deeply unsettling and profoundly awe-inspiring. Yet, our galaxy is not uniquely defined by crushing blackness and gravitational shadows. It is also filled with breathtakingly luminous clouds of gas and dust, the raw, unshaped material of future stars glowing in vibrant colors that remain completely invisible to the naked eye, but are gloriously revealed by our most powerful telescopes. These are the nebulae, and they are without a doubt some of the most beautiful and intricate structures in the entire universe. Some of these glowing clouds are active star-forming regions, vast cosmic nurseries where the gentle, persistent pull of gravity draws ancient hydrogen gas together until the intense pressure ignites the fires of nuclear fusion. The Orion Nebula is one of the closest of these nurseries to us, a glowing ethereal patch just barely visible with ordinary binoculars hanging just below the famous belt of Orion. When viewed through the lens of a telescope, it suddenly appears as a magnificent swirl of deep pinks and vibrant purples, intensely illuminated from within by the fierce radiation of young, incredibly hot stars deeply embedded inside its gaseous folds. This is the exact place where new suns are actively being born, where completely new planetary systems are just beginning their long, slow dance out of the dark. Other nebulae in the galaxy are not nurseries, but rather the haunting, beautiful remnants of dead stars. The Crab Nebula, for instance, is the chaotic, expanding aftermath of a massive supernova explosion that was actually recorded by ancient Chinese astronomers in the year 1054. For weeks, that cataclysmic explosion was so intensely bright that it was plainly visible in the middle of the day. What remains of it now is a rapidly expanding, highly structured cloud of gas and intricate filaments, glowing fiercely from the relentless energy of a rapidly spinning neutron star left behind at its very heart. To look at the Crab Nebula is to witness the violent end of the life cycle of stars made beautifully visible, a moment of profound death miraculously transformed into enduring cosmic beauty. Planetary nebulae represent yet another form of this stellar afterlife. These are the delicate, glowing shells of gas gently shed by dying, sun-like stars as they reach the final stages of their existence. Despite their somewhat misleading name, they have absolutely nothing to do with planets. The early astronomers who first named them simply thought they looked round and planet-like when viewed through their small, primitive telescopes. In reality, they are the beautiful, quiet last breath of a star, very much like our own sun. Their outer layers are cast gently outward into the frigid depths of space, shining softly from the residual heat of the fading, exposed core within. These delicate, ethereal structures come in almost every shape imaginable, perfect rings, spreading butterflies, elegant hourglasses, each one uniquely sculpted by stellar winds, complex magnetic fields, and the sheer chance of cosmic physics. They last for only tens of thousands of years, a fleeting, brief moment in the grand scale of cosmic time before their gas slowly dissipates and fades completely into the interstellar medium. Between these sprawling clouds of gas and the scattered remnants of dying suns, star clusters also dot the vast expanse of the Milky Way. Open clusters, like the famous Pleiades, are groups of young, vibrant stars that were all born together from a single, massive cloud of gas, still drifting through space as a loosely bound family before they eventually scatter across the galaxy. They are bright, tight, glittering groups that are relatively easy to spot in the dark night sky. Globular clusters, by striking contrast, are ancient, tightly packed spherical collections containing hundreds of thousands of stars, orbiting far out in the lonely halo of the galaxy. They are older than almost all of the stars found within the flat galactic disk, serving as glowing, spherical fossils of an earlier age, still burning steadily after billions of years. To look at a globular cluster through a telescope is to peer directly back into the extremely early days of the Milky Way, to a time long before the Earth itself had even begun to form. All of these incredible wonders, the silent black holes, the glowing nebulae, the ancient clusters, remind us that the galaxy is deeply alive with complex, ongoing processes. Stars are born, they live out their lifespans, they die, and their scattered remnants go on to shape the empty space around them. Massive gas clouds collapse under their own weight to form entirely new generations of light. Violent explosions scatter the heavy elements necessary for life. Clusters hold together for eons or slowly dissolve into the background. Black holes pull, twist, and fundamentally bend the fabric of space-time itself. The Milky Way is not a static, frozen collection of stars locked in place, but a highly dynamic, breathing system that is constantly evolving and constantly recycling its own matter. When you step outside on a quiet, still night and look up, you do not see these specific wonders directly. You see only the pinpricks of the stars. But through the lenses of telescopes, through careful, patient observation across the entire spectrum of light, radio, infrared, ultraviolet, X-rays astronomers have successfully revealed this deeply hidden side of the galaxy. What looks to our eyes like completely empty space often glows brightly and vividly at other wavelengths. Thick dust that completely blocks visible starlight shines warmly in the infrared. Black holes, entirely invisible in normal light, blaze with terrifying intensity in X-rays. The universe is infinitely richer, infinitely more complex than our eyes alone could ever reveal. And perhaps that is the most striking, beautiful part of it all. Our galaxy holds not just a multitude of stars, but physical phenomena so extreme, so bizarre, that they completely stretch the limits of our understanding. Black holes where gravity is absolute and inescapable. Nebulae, where stars are violently born or beautifully die. Clusters that preserve the deep memory of billions of years. Each one is a profound reminder that the Milky Way is not just unimaginably large, not just filled with stars, but also filled with variety, with high drama, with a profound beauty that comes from physical processes too vast and too long-lived for us to ever witness in their entirety. When you step back and try to take in the Milky Way as something far more than just the sum of its stars and its hidden wonders, you begin to realize that what surrounds us is not merely a sprawling city of suns, but an ocean. It is a cosmic ocean so impossibly vast that even light, the absolute fastest traveler we know of in nature, takes a full 100,000 years just to cross from one shore to the other. To even try to imagine such a journey is to attempt to sail across something that makes every earthly sea, every vast ocean on our planet, seem like a tiny, insignificant puddle in comparison. This is exactly what it means to attempt to cross the galactic sea. Our own solar system sits comfortably about halfway between the glowing, turbulent center of the Milky Way and its quiet, fading outer edge, nestled safely within a smaller spur of one of the great spiral arms. From this vantage point, the galaxy stretches outward in all directions, forming a massive disk 100,000 light-years across. If you could somehow rise far above it and look down upon its face, you would see a glorious, glowing pinwheel, a majestic spiral of light and swirling dust. But from our position inside it, what we experience is the daunting, unimaginably long journey across its width. It is a sea where every single star is an isolated island, every glowing nebula a distant lighthouse, and every dense star cluster a bustling port along the way. To cross such a sea, even in the safety of our own thoughts, means accepting distances that completely strain the boundaries of human imagination. Our nearest stellar neighbour, Proxima Centauri, is 4 light-years away. In the context of this ocean, that is like the very first buoy bobbing just beyond our local shore. The rest of the galaxy stretches for 100,000 of those massive units. If you tried to compare this to any form of earthly travel, you would fail almost immediately. Driving across a large continent feels like a long journey. Flying across an ocean feels like a significant distance, but those trips are measured in mere hours or days. To cross the galaxy would take 100,000 years, and that is only if you were travelling at the absolute speed of light. The sheer scale of it makes human travel feel like the frantic, tiny flapping of a moth's wings inside a cavernous, echoing cathedral. And yet, this vast sea is by no means empty. Scattered all along the way are stars of every conceivable kind. There are the bright, massive blue giants that burn incredibly hot and die fast, raging against the dark. There are the small, cool red dwarfs that flicker patiently for trillions of years, outlasting almost everything else. There are white dwarfs and rapidly spinning neutron stars, the dense remnants of violent explosions drifting through the dark like ancient wreckage. Planetary systems are scattered everywhere throughout this expanse. Some might look somewhat familiar in their form, while others would be entirely alien, defying everything we know about how worlds should look. Crossing the galactic sea would mean sailing past them one after another, endlessly. Each one is a complex world of its own, each one carrying a unique story of formation, violent change, and quiet evolution. Imagine, just for a moment, setting out from our sun and heading directly toward the galactic center. At first, the stars would be relatively thin, the dark gaps of interstellar space wide, lonely, and profoundly quiet. But the closer you drew to the beating heart of the galaxy, the more crowded and chaotic the waters would become. Near the core, stars are packed so incredibly densely that if you happen to live on a planet orbiting one of them, the night sky would blaze with dozens of bright, distinct suns. The sky would never truly be dark. Instead, it would glow with a relentless overlapping light from every conceivable direction. Between those tightly packed stars, massive black holes lurk in the shadows, pulling violently at the very fabric of space, bending the paths of passing objects, and heavily distorting the light of the stars behind them. Navigating through that region would be exactly like sailing into a violent, churning storm, a place where gravity itself becomes turbulent and unpredictable. If, instead, you chose to sail outward toward the far rim of the galaxy, the exact opposite would happen. The stars would gradually thin out and fade, the distances between them growing wider and wider until only sparse, lonely outposts remained in the dark. Beyond the edge of the flat disk, you would rise upward into the galactic halo, an expansive, ghostly region where old, dim stars and ancient globular clusters orbit quietly in the absolute cold. From that high vantage point, you could look back down at the Milky Way itself, finally seeing it in its entirety as a magnificent, glowing spiral suspended across the infinite dark. Crossing outward feels exactly like leaving the bustling, noisy ports of a crowded coastal city and heading out into a quiet, endlessly deep and solitary sea. One of the most curious and fascinating things about the galactic sea is just how highly structured it actually is. The grand spiral arms that define its shape are not physical ropes tying the stars together, but rather immense density waves, regions where the traffic of stars and gas naturally becomes more concentrated and compressed. As you move slowly through them, you would encounter massive bursts of star formation, young stars, blindingly bright and intensely hot, would light the way forward. Massive gas clouds would glow with radiation. Vibrant nebulae would bloom like flowers in the dark. Then, as you sailed out of the arm and passed into the wide spaces between them, things would grow much quieter, the stars older, their light significantly dimmer. It would be exactly like moving from a chain of bustling, brightly lit islands into the calm, empty stretches of open, deep water. Over millions of years, the stars slowly orbit the center, the spiral arms shift their positions, and entirely new structures form from the cosmic dust. The sea is never truly still. Crossing it also reveals the terrifying scale of cosmic time. The Sun itself takes approximately 200 million years to complete, just one single orbit around the center of the galaxy. That means in the 4.5 billion years since the Earth first formed from a spinning disk of dust, our solar system has circled the galaxy more than 20 times. Every single orbit carries us gracefully through the dense spiral arms and out into the quiet spaces between them, past chaotic, crowded regions and sparse, lonely ones. Here on our tiny planet, entire civilizations rise and inevitably fall. Massive continents form, break apart, and drift across the oceans. Millions of species evolve, thrive, and eventually vanish into the fossil record. All of this happens while the Sun simply sails on, carrying us relentlessly through the galactic sea without a single pause. It is deeply humbling to think that the night sky we see is entirely temporary. The familiar constellations that look so permanent, so fixed in human history, are merely temporary arrangements dictated by our current position in the cosmic ocean. As the Sun continues its long orbit, the patterns will inevitably shift. Stars will move relative to us, some fading into the distance, some brightening as they draw near, some replaced entirely by newcomers emerging from the dark. 100 million years from now, the sky above Earth will be completely unrecognizable. The galactic sea is not a frozen, unchanging map. It is a powerful, sweeping current carrying us through a constantly changing, evolving landscape of stars. Even the most distant, isolated places in this sea are intimately part of the same grand whole. Globular clusters, those dense spherical swarms of ancient stars, orbit far above and below the main disk. Some of these clusters contain hundreds of thousands of suns packed so tightly together that they look like a single, glowing orb. These clusters are like floating, isolated islands in the halo, serving as quiet reminders of the galaxy's earliest, most turbulent days. Their stars are older than our Sun, older than the Earth, older than the very concept of life itself. To visit one of these clusters would be to look directly into the deep past, to see the galaxy exactly as it was billions of years ago. Then there are the stellar streams, long, ghostly rivers of stars that trace elegant paths across the halo, the sad remnants of smaller dwarf galaxies that were violently torn apart by the Milky Way's immense gravity. They weave through the dark like trails of cosmic debris, serving as undeniable evidence of our galaxy's continuous growth and hunger, because the Milky Way has not always been exactly as it is now. Over billions of years, it has actively absorbed smaller galaxies, pulling them in relentlessly, mixing their foreign stars with its own native population. To cross the galactic sea is to see not only stars, but deep history written clearly in their complex motions, in their unique chemical fingerprints, and in the specific way they orbit the center. Yet, for all its blinding light and swirling color, this vast cosmic ocean holds a deeper, invisible secret, a profound darkness that we cannot see directly, but which quietly dictates the fate of every single glowing world. The stars, the nebulae, the brilliant clusters, these are only the visible crests of the cosmic waves. Beneath them, surrounding them, permeating every seemingly empty gulf of the Milky Way, lies dark matter. It does not glow with the fierce heat of a newborn sun. It does not absorb light like the thick clouds of interstellar dust. It remains entirely silent, an untouchable phantom. Yet, its gravity acts as the invisible scaffolding of the entire galaxy. Without this unseen mass, the outer stars, spinning at dizzying speeds, would simply fly apart, drifting away into the cold void like untethered ships. With it, they are held securely in their orbits, anchored by a force we can only detect through the subtle ways it bends and shapes the light around it. Astronomers estimate that this dark matter makes up the vast majority of our galaxy's mass. If you were to cross the galactic sea, you would not see this dark architecture, but you would feel its relentless pull, holding the great spinning wheel together. And then there is the peculiar nature of our perspective from within this cosmic wheel. When we look up from Earth, we see the Milky Way as a faint, pearlescent band painted across the night sky, simply because we are embedded deep inside the disk, looking out along its flat plane. From another vantage point, suspended far out in the intergalactic void, we would see it edge on, appearing as a razor-thin streak of brilliant light cutting across the absolute dark. If we could somehow rise millions of light-years above it, we would look down to see the majestic spiral arms unfolding like the luminous petals of a cosmic flower. Each shift in viewpoint profoundly changes our sense of scale, yet no matter the angle, the Milky Way remains incomprehensibly immense. Crossing it is not a physical journey any biological being could ever hope to complete. It is a voyage of thought, a journey of pure imagination carried on the back of light itself. Perhaps the most striking realization of all is that we are, in fact, always crossing it. At this very moment, as you rest quietly, the sun is carrying us forward on a grand voyage. We do not feel the rush of the cosmic wind, but we are moving at hundreds of kilometers every single second, locked in a massive orbit around the galactic center, threading our way delicately through the dense spiral arms. The Earth turns on its axis. The solar system drifts. The galaxy itself rotates in the dark. This galactic sea is not a body of water to cross just once and leave behind. It is an ocean we are sailing through continuously, every second of our lives, whether we look up to notice it or not. When you finally manage to step back from the Milky Way, allowing your mind to view it not as the entirety of existence, but merely as one single component of a much larger gathering, a completely new layer of scale comes into sharp focus. Our home galaxy, as immense and overwhelming as it feels, is not a solitary wanderer in the dark. It belongs to a family. It is part of a group of galaxies bound together by the inescapable tether of gravity, drifting through the wider cosmos as lifelong companions. Astronomers call this family the local group. The name sounds deceptively simple, almost casual, as though it were a mundane neighborhood association. But in reality, it refers to a staggering collection of dozens of distinct galaxies spanning millions of light-years of space, all moving in a complex gravitational choreography, sharing a common, inescapable destiny. This local group is anchored by two massive dominant giants, the Milky Way and the Andromeda galaxy. These are the undisputed rulers of our cosmic neighborhood, each containing hundreds of billions of stars. Andromeda, also known to astronomers by its catalogue name M31, is slightly larger than our own galaxy, stretching an awe-inspiring 250,000 light-years across. If you step outside on a clear, moonless night, far from the glare of city lights, you might just be able to spot it. From Earth, it appears as nothing more than a faint, elongated smudge of pale light in the constellation of Andromeda, barely visible to the naked eye. Yet, that unassuming, faint smudge is the combined, blazing light of a trillion individual stars. That light has been traveling through the freezing vacuum of space for more than 2 million years just to reach your eyes tonight. To look at Andromeda is to look across an unfathomable gulf of both space and time, catching a fleeting, ancient sight of our closest large neighbour. Between the Milky Way and Andromeda, a slow, inevitable dance is taking place. These two galactic behemoths are not static. They are currently hurtling toward each other at phenomenal speeds. In about 4 billion years, this dance will reach its dramatic climax, and the two galaxies will collide. The word collision sounds violent, conjuring images of catastrophic destruction, but in galactic terms, it will be something far more elegant. It will be an interweaving. The distances between individual stars are so unimaginably vast that very few, if any, will actually strike one another directly. Instead, the two galaxies will pass through each other like ghosts. Their majestic spiral shapes will be violently distorted by gravitational tides, their beautiful arms stretched and torn, their billions of stars flung into wild, unfamiliar new orbits. Over billions of years, the chaos will eventually settle, and they will merge completely to form a single, massive, elliptical galaxy, a future home that astronomers have playfully nicknamed Milkomeda. To think of this future merger is to realize a profound truth about the cosmos. Even galaxies are not permanent. They are not eternal monuments carved into the dark. They live, they move, they interact, and they change, just like the stars and planets within them. The local group is not a frozen diorama. It is alive with continuous sweeping motion. Beyond the two reigning giants, there is a diverse cast of smaller companions. The Triangulum Galaxy, or M33, is the third largest member of our family, though it is significantly smaller than both the Milky Way and Andromeda. It is a delicate, beautiful spiral, rich with the chaotic energy of star formation, shining brightly with dense star clusters and glowing nebulae. Then, there are the dwarf galaxies. There are dozens of them scattered like a swarm of fireflies around the larger spirals, bound as eternal satellites. The large and small Magellanic Clouds, visible from the Earth's southern hemisphere as irregular, glowing patches against the dark, are the most prominent of these attendants. They are true galaxies in their own right, each containing billions of stars, but when compared to the sheer bulk of the Milky Way, they seem tiny, like children trailing faithfully alongside a parent. This is one of the most striking, sobering things about the local group. It is not a peaceful, static collection of independent islands. It is a dynamic, evolving, and sometimes ruthless system. Galaxies fall into one another's gravitational wells. They orbit, they merge, they dissolve, and they consume. The Milky Way has cannibalized many smaller dwarf galaxies over its long lifespan. The stars of those consumed galaxies are now thoroughly mixed into our own galactic halo, their origins masked by time. Long, ghostly streams of stars, ribbons of ancient light stretching across the sky, are the only remaining evidence of these ancient cosmic meals. The local group is a place of endless interaction, not a place of isolation. In terms of sheer size, the local group stretches roughly 10 million light-years across. That number is easy to say, but almost impossible to truly imagine. It means that a beam of light, travelling at the absolute speed limit of the universe, would still take 10 million years just to cross from one side of our local neighbourhood to the other. The dozens of galaxies within this group are spread across this vast, dark region like scattered islands in a sprawling, silent archipelago. Some are huddled close together, like the Milky Way and its attendant dwarfs, engaged in their intimate gravitational dances. Others are stationed much farther apart, drifting lonely and isolated on the extreme outskirts of the group. Yet, despite the staggering distances separating them, All of them are inextricably bound by gravity into a single, shared system. Between the outer edge of the Milky Way and the outer edge of Andromeda, there are over 2 million light-years of absolute emptiness, a void filled only with the incredibly thin, cold gas of intergalactic space. The local group is a community, undoubtedly, but it is a community where the neighbours live incredibly far apart. What makes the local group so deeply captivating is the delicate balance it holds in our understanding. On the one hand, it is vanishingly small when compared to the universe as a whole. There are clusters of galaxies out there that are far larger, containing not dozens, but hundreds or even thousands of massive members. On the other hand, it is terrifyingly vast when compared to our galaxy alone. 10 million light-years is a distance that already pushes the absolute limits of human imagination. Yet, it is close enough that we can actually map it in exquisite detail, measure the distances between its islands, trace the complex orbits of its members, and even detect the faintest, most ghostly dwarf galaxies hiding in the dark. It is local not because it is physically small, but because it is the immediate space around us that we can just barely begin to grasp. When you look up on a dark night and see the faint, hazy glow of Andromeda, you are looking directly across that terrifying gulf to the next great island of stars. You are seeing a piece of the local group with your own, unaided eyes. That faint smear in the night sky is not just a blur of light. It is an entire other galaxy, another sprawling, bustling city of stars moving steadily toward us, bound together with us in the exact same gravitational family. But once you finally manage to take a step back from the local group, something truly remarkable begins to happen to the architecture of the cosmos. The galaxies that seemed so incredibly spread out, with millions of light-years of empty, freezing void between them, suddenly start to look close together again. This happens because the scale of our perspective has shifted once more. Now, you are no longer thinking about single galaxies, or even small, intimate groups of them. You are pulling back to see the much larger gatherings, the massive cosmic intersections where dozens or even hundreds of massive galaxies are bound tightly together by gravity, forming what astronomers call clusters. And when those massive clusters themselves are arranged into still larger, sweeping patterns, connected by glowing filaments and dark threads of matter, you have superclusters, some of the grandest, most overwhelming structures known to exist in the universe. A true galaxy cluster is not like a small, quiet family of galaxies such as our local group. It is much bigger, much denser, and often a far more dramatic, violent environment. The Virgo cluster, for example, is the nearest large cluster to our own position in space. It lies roughly 50 million light-years away, and it contains not a dozen or two, but over 1,000 individual galaxies. Imagine that for a moment. Thousands of vast, swirling spiral and massive elliptical galaxies, each one brimming with hundreds of billions of stars, all bound together in a chaotic, inescapable gravitational knot. When you point a telescope toward the constellation of Virgo on a clear night, many of the faint, glowing smudges you see are not individual stars, but entire galaxies belonging to this massive cluster. It is so incredibly massive, its gravitational pull so overwhelming, that our entire local group is currently drifting slowly toward it, drawn inexorably into its depth. Though that journey will take billions of years to complete, it is important to understand that clusters are not gentle, peaceful places. They are incredibly crowded cosmic arenas where galaxies frequently collide, merge, or violently distort one another with overwhelming tidal forces. When two massive galaxies crash together within a cluster, their individual stars almost never collide directly, because the distances between stars are simply too great. But their vast, sprawling clouds of interstellar gas certainly do. They slam into one another, compressing violently and igniting massive, brilliant new waves of star formation that light up the dark. Their beautiful, symmetrical shapes are pulled and stretched beyond recognition, their spiral arms twisted into chaotic ribbons, their dense cores disrupted and reshaped. Over immense stretches of time, these clusters evolve. Smaller galaxies are relentlessly pulled in, merging into larger and larger bodies. The inevitable result of this cosmic cannibalism is that many clusters are dominated by absolutely giant, featureless elliptical galaxies sitting dead at their centers, the silent, bloated outcomes of countless ancient mergers. These central giants can be hundreds of thousands of light-years across, dwarfing the Milky Way, glowing with the combined blinding light of trillions of stars. And yet, the space between the galaxies within a cluster is not a peaceful, empty void. It is filled with something entirely unexpected, vast, swirling amounts of incredibly hot, thin gas. This intra-cluster medium, as astronomers call it, is heated to millions of degrees by the sheer gravitational friction of the cluster, causing it to glow fiercely in X-rays. Though it is completely invisible to our human eyes, this searing plasma actually makes up far more mass than all the billions of stars in all the galaxies combined. To cross a galaxy cluster is not to sail through dark, empty space, but to wade through a turbulent, churning sea of hot plasma, constantly stirred by immense gravity and cosmic turbulence. This gas is rich with heavy elements, the scattered ashes of countless supernovae blown outward over billions of years. It is the literal breath of dying galaxies, filling the spaces between them. But clusters contain something else too. Just as in individual galaxies, the visible matter, the trillions of stars and the oceans of searing plasma is simply not enough to explain the immense gravity that holds the cluster together. The galaxies are moving far too fast. The gas glows too brightly from its intense heat, and it would easily escape into the void unless something unseen, something immensely heavy, kept it bound. That something is dark matter, once again making its presence known, outweighing absolutely everything we can see by a staggering margin. Clusters, then, are not just random gatherings of glowing galaxies. They are the undeniable evidence of the invisible scaffolding of the universe. They are the massive, unseen skeleton of dark matter around which all light, all gas, and all visible matter are forced to arrange themselves. If galaxy clusters are the bustling, crowded neighborhoods of the cosmos, then superclusters are the sprawling, interconnected cities. A supercluster is a staggering collection of many individual clusters, all linked together by gravity across hundreds of millions of light-years of space. Our local group, along with the massive Virgo cluster it is falling toward, is part of the Virgo supercluster. Yet, incredibly, even this massive structure is itself only a small peripheral piece of an even larger, more mind-bending formation called the Laniakea supercluster. Laniakea is immense beyond all human reckoning. It spans over 500 million light-years of space and contains the mass of roughly 100,000 galaxies. It is so terrifyingly vast that even a beam of light, travelling at the maximum speed allowed by the laws of physics, would take 500 million years just to cross from one edge to the other. That is a span of time longer than complex life has even existed on the planet Earth. The name Laniakea comes from the Hawaiian language, meaning immense heaven, and as you try to hold the sheer scale of it in your mind, you realize just how fitting that name truly is. To comprehend this structure is to imagine looking at the universe, not galaxy by galaxy, not cluster by cluster, but in terms of vast, sweeping cosmic flows that carry everything toward an unknown destination. Galaxies, you see, are not static monuments frozen in the dark. They are in constant, sweeping motion, carried relentlessly by the pull of gravity. By mapping these slow-motion rivers of light, astronomers discovered that the Milky Way, the local group, and even the massive Virgo cluster are all drifting together. We are moving toward the exact same region of space, a colossal gravitational basin known as the Great Attractor. This mysterious region lies deep at the center of Laniakea, where the combined mass of tens of thousands of galaxies bends the paths of absolutely everything nearby. It is less like a physical place and more like a torrential gravitational current, a tremendous sink at the bottom of the cosmic sea. To belong to Laniakea is to be carried within that silent, unseen current, drifting along with all the countless galaxies that surround us. It is here that the true sense of scale begins to overwhelm the mind. Think once again of the light year. Our local group stretched across about 10 million of them. The Virgo cluster lies tens of millions of light years away, but Laniakea stretches across 500 million. With each step outward, we leap an order of magnitude larger, pushing far beyond the mind's usual comfort zone. And yet, these are real, physical structures mapped and measured by human minds, not mere abstractions. Clusters and superclusters are simply the way matter naturally organizes itself on the absolute largest scales. If you could hover outside a supercluster and look back upon it, you would not see a single cohesive shape like a spiral galaxy. Instead, you would see a loose scattering of galaxies and clusters, strung along faint filaments, connected in sprawling patterns. It would not look crowded. Rather, it would appear surprisingly delicate, woven like luminous lace or a fragile web against the absolute black. This is because even a supercluster is mostly composed of empty space. The galaxies themselves are tiny compared to the yawning distances between them, but when viewed from afar, the pattern undeniably emerges. It is a structure so vast it defies direct experience, and these grand structures are not fixed forever. Over immense stretches of time, the relentless expansion of the cosmos stretches the space between them. Galaxies not bound by gravity to one another will eventually drift apart, carried away on the swelling tide of the expanding universe. Superclusters themselves may someday fragment, their members carried away beyond the reach of light. But for now, in our sliver of cosmic time, they exist, and we can see them, we can map them, name them, and trace their glowing edges. The very existence of clusters and superclusters reminds us of how matter clumped together in the first place. After the Big Bang, matter was almost evenly spread throughout the expanding void, save for microscopic fluctuations in density places infinitesimally denser here, slightly thinner there. Over billions of years, gravity patiently went to work, pulling more matter into the denser spots. Those pockets grew, igniting into galaxies, which gathered into groups, then clusters, then superclusters. The immense structures we see today are simply the grown-up forms of those infant ripples, the echoes of the early universe written in stars. Counting these clusters is reading the after-effects of the beginning itself. And even here, we have not reached the largest scale, because superclusters are not isolated islands. They are part of an even greater pattern, the cosmic web, where filaments of galaxies stretch across billions of light years, separated by terrifying voids. Imagine yourself untethered, drifting slowly among them. You pass the Milky Way, move beyond the local group, and watch Andromeda fall behind. Ahead, the colossal Virgo cluster begins to rise, its thousands of galaxies glowing in every direction. Beyond that, the clusters stretch on, linked by faint threads into a larger whole. The sky is not just filled with scattered stars, it is filled with immense, interconnected structures, too large for any one lifetime to cross, but visible and knowable through the patience of science. As you move beyond the superclusters, you begin to see that even those immense gatherings are not the final picture. There is another layer, a structural architecture that reveals itself only when you look at the universe as a singular entity. Astronomers call it the cosmic web. It is the grandest structure we know, a vast network of glowing filaments, dense clusters, and dark voids woven together like threads of light stretched taut across the infinite dark. The existence of the cosmic web was not obvious until recently. For centuries, the night sky seemed like a random scattering of stars, and even galaxies seemed placed without rhyme or reason. But as astronomers mapped their precise positions in 3 dimensions, a breathtaking pattern emerged. Galaxies were not evenly distributed like sugar across a table. Instead, they gathered into long chains and sprawling sheets, with enormous empty regions between them. These empty spaces, known as voids, can span hundreds of millions of light years, almost entirely devoid of galaxies. Between them, the galaxies form filaments, narrow highways of matter where gravity has drawn them together. When you step back far enough, what you see looks exactly like a web, intricate and interconnected, spanning the universe itself. Imagine zooming out from the local group once more. First, you see the Virgo supercluster, then the sprawling mass of Laniakea stretching 500 million light-years across the dark. But as you go farther, you notice that Laniakea is just one single strand among countless many. Other superclusters lie nearby, connected by luminous filaments, separated by yawning voids. Together, they form something that looks eerily like a spider's web stretched across space. If you could look down on it from above, it would look like a delicate, patterned lace. The filaments glow faintly with the light of galaxies, while the voids sit almost completely empty, vast dark bubbles where almost nothing resides. The web itself formed from the earliest moments of the universe, an initial blueprint stretched into its adult form. The filaments can be hundreds of millions of light-years long. Within them flow galaxies, superclusters, and vast amounts of dark matter, while thin gas courses along these cosmic highways feeding their growth. The voids, by contrast, are quieter, nearly empty expanses where galaxies are exceptionally rare. They are the silent deserts between the filaments, stark reminders of the unevenness of the universe's grand design. What is perhaps most striking is how strangely familiar the pattern looks. Images of the cosmic web resemble networks we know intimately, the branching neurons in a human brain, the sprawling filaments of fungi hidden in the soil, the complex branching of ancient trees. Nature, it seems, strongly favors networks. It gives a strange, quiet comfort to think that the absolute largest structure we know to exist shares a visual resemblance to the intricate structures hidden deep within us. If you were somehow able to drift freely through the cosmic web, you would spend the vast majority of your time in absolute darkness. The filaments are separated by enormous stretches of void, and traveling from one to another would take longer than the entire history of life on Earth. But along the way, you would pass through regions where galaxies crowd tightly together, where massive clusters blaze with invisible X-rays from superheated gas, where brilliant new stars light up in sprawling nebulae. It would be like sailing between distant continents across a dark, endless ocean, long, silent stretches of emptiness broken only occasionally by vibrant, glowing shores. The cosmic web also serves as a profound reminder that even the largest structures in reality are temporary. The universe is expanding, and with time, galaxies not bound by gravity will inevitably drift apart. Over billions and trillions of years, the web will thin out, the glowing filaments will stretch, and the dark voids will grow ever larger. From our perspective right now, we can still see the web in its magnificent glory. We can map the filaments and trace the slow, gravitational flows. But in the incredibly far future, distant civilizations may not be able to see it at all. The relentless expansion of space will carry the vast majority of the web far beyond their view. What feels like a permanent structure to us now is, in cosmic terms, merely a passing phase. And yet, This temporary web is our ultimate context. Our home is not just a galaxy or a group of galaxies. It is one single, microscopic node in a network stretching across the entirety of the universe. To truly know this is to shift your perspective once again. First Earth, then the solar system, then the Milky Way, then the local group, then the superclusters, and now, finally, the cosmic web. When astronomers create detailed maps of the cosmic web, they often show it glowing with vibrant false colors, filaments lit in striking blues or brilliant yellows, the massive voids rendered completely dark. These images are perfectly accurate in their shape, and even in those detailed maps, the sheer, overwhelming emptiness dominates the frame. Most of the universe is simply void. The sprawling filaments and burning stars are the rare structures, the beautiful exceptions in an otherwise dark expanse. The cosmic web is delicate because it is incredibly sparse, a fragile lace stretched across unfathomable emptiness. But sparse does not mean unimportant. It is exclusively along these filaments that galaxies form, where stars ignite, where planets coalesce, and where life eventually emerges. The web is the grand stage upon which absolutely everything we know plays out. Imagine looking at it from the outside, seeing billions of light years across, glowing faintly with the light of countless suns, voids spreading outward like great dark bubbles. You would realize that the spiral galaxy you call home is just one tiny dot along one of those filaments, a single bead on a thread stretching across eternity. And still, incredibly, the web is not the limit. Even after mapping these sprawling filaments and massive voids, there is another, deeper question waiting in the dark. How many of them are there? How many individual galaxies, in total, fill this sprawling cosmic web? When we speak of stars, the numbers already feel overwhelming. But when you step out to the scale of galaxies, the count expands into something even harder to hold in the mind. It is one thing to know that each galaxy is a sprawling city of stars. It is another entirely to realize just how many of those illuminated cities exist. Counting them is a monumental project that stretches our instruments, our mathematics, and our imagination. For a long time, astronomers had no real sense of the number. Before powerful telescopes, the Milky Way was thought to be the entire universe. The faint, blurry smudges in the night sky, like Andromeda, were thought to be mysterious nebulae, perhaps just local clouds of glowing gas. It was only in the early 20th century that astronomers realized those smudges were not clouds within our galaxy at all, but entire galaxies of their own, as large or larger than the Milky Way, each holding billions of individual stars. The scale of the universe expanded in an instant. What had looked like a foggy patch in the night was actually a vast, swirling spiral 2 million light-years away. As telescopes grew more powerful, the faint patches multiplied across the sky. The Hubble Space Telescope, launched in 1990, offered one of the clearest, most profound glimpses into this reality. Astronomers pointed it at what looked like a completely empty, dark piece of sky. They chose a patch no larger than the tip of a pin held at arm's length, a void where absolutely nothing was visible, and they simply let the telescope gather light for days on end. The result was the Hubble Deep Field. It was an image filled not with the expected emptiness, but with thousands upon thousands of galaxies, each one a unique swirling shape, each one a distant island of stars, waiting quietly in the dark to be seen. The lesson drawn from that tiny, illuminated pinprick of darkness was immediate and profoundly humbling. If a fraction of the sky, no larger than a grain of sand held at arm's length, could contain thousands of galaxies, then the entire unbroken canopy of the heavens must hold hundreds of billions. As our instruments have grown sharper and our gaze has pierced deeper into the cosmic dark, that number has only continued to climb. Current estimates suggest that the observable universe contains at least 2 trillion galaxies. 2 trillion. It is a number that sits so high above our daily reality that it tends to simply slide past our comprehension, leaving only a vague sense of vastness. But let us try, for a moment, to anchor it to something we can feel. Think about the steady, relentless ticking of a clock. 1,000,000 seconds will pass by in about 11.5 days. 1,000,000,000 seconds is a much longer journey, taking just over 31 years to unfold. But 1,000,000,000,000 seconds? To count 1,000,000,000,000 seconds, you would need to wait for more than 31,000 years. Now, double that. 2 trillion galaxies means 2 trillion sprawling cities of stars, each one of them burning with billions or even trillions of individual suns. If you were to multiply the number of stars in an average galaxy by the number of galaxies in the observable universe, you reach a figure so incomprehensibly massive that it makes every single grain of sand on Earth feel like a pitifully small collection. It is a comparison that has been made many times, yet it never loses its weight. There are more stars in the universe than there are grains of sand on all the beaches, all the deserts, and all the ocean floors of our entire planet combined. To count them all, even at a rapid pace of 1 star per second, would take far longer than the current age of the universe itself. And yet, the act of counting these distant islands is not a hopeless endeavour. Astronomers do not sit and tally them one by one, like a merchant counting coins in a ledger. Instead, they measure the light. They gather the incredibly faint, ancient glow seeping in from the deepest reaches of space, measure its intensity, and use the strict laws of physics to infer exactly how many galaxies must exist to produce such a luminous background. They rely on massive projects like the Sloan Digital Sky Survey, which painstakingly maps millions of galaxies across large swaths of the sky, allowing scientists to extrapolate the rest. They peer through the lenses of the Hubble, and now the magnificent James Webb Space Telescope, capturing infrared whispers from galaxies that are far too faint, too small, or too distant for earlier generations of instruments to perceive. With every technological advance, the estimate is pushed higher, revealing a universe that is infinitely richer, more crowded, and more complex than we ever dared to imagine. This staggering quantity is matched only by an equally breathtaking diversity. Not all of these 2 trillion galaxies are sweeping, majestic spirals like our Milky Way or the neighbouring Andromeda. The cosmic ocean is filled with a vast menagerie of shapes and forms. Many are ellipticals, colossal, smooth, and featureless spheres of ancient red stars, often born from the violent, slow-motion mergers of smaller galaxies colliding over eons. Others are classified simply as irregulars, their shapes twisted, shattered, or drawn out into long, chaotic tails by the relentless gravitational tides of their neighbours. There are tiny dwarf galaxies, faint and fragile, holding only a few million stars, clinging desperately to the edges of larger systems. And there are the true giants, monstrous elliptical behemoths reigning at the centres of massive clusters, containing trillions of suns within their gravitational embrace. Counting these galaxies is not merely a mathematical exercise. It is an act of recognizing that every single one of them is entirely unique, sculpted by its own specific history of isolation, collision, and the slow, grinding passage of cosmic time. The most distant of these galaxies push the very limits of what it is physically possible for us to see. Because light takes time to travel, looking across such immense gulfs of space is exactly the same as looking backward through time. The light from the farthest galaxies we can detect has been travelling across the void for over 13 billion years to reach the lenses of our telescopes. This means we do not see them as they are tonight. We see them exactly as they were when the universe was still in its infancy. In those ancient snapshots, galaxies appear small, chaotic, and irregular, often blazing with the furious, brilliant light of new star formation. They serve as a poignant reminder that galaxies, much like the stars they contain, have lifetimes. They are born, they grow, they collide, they merge, and they slowly evolve. The grand, sweeping spirals and the massive, quiet ellipticals we see in our local cosmic neighborhood today were once smaller, chaotic fragments crashing together in the dark. To count the galaxies is also to count the varied stages of their lives, creating a grand census not only of sheer quantity, but of cosmic age. But we must remember a crucial caveat. 2 trillion is the estimated number of galaxies within the observable universe. It represents only that specific portion of the cosmos from which light has had enough time to reach us since the universe began. Beyond that boundary, we simply do not know what awaits. The universe may very well be infinite in its true extent. If it is, then the actual number of galaxies is not 2 trillion, it is uncountable, stretching on without end. The observable horizon is not a physical wall, not a barrier made of matter or energy. It is simply a limit defined by the speed of light and the passage of time. Beyond that invisible horizon, there may be more galaxies, more stars, more worlds, stretching out forever into an endless dark. Our count, as staggering as it is, represents only the fraction of the whole that we are permitted to see. Still, even that visible fraction is enough to bring the mind to a complete standstill. Imagine, if you will, standing on a quiet beach in the dead of night. You can hear the rhythmic, soothing sound of the waves rolling in, and you can feel the cool, damp sand beneath your bare feet. You bend down, scoop up a single handful of that sand, and let the tiny, coarse grains slip slowly through your fingers. Now, imagine that every single grain touching your skin is an entire galaxy. Then, expand your mind to picture the whole beach made of galaxies. Then, every beach on Earth, every desert, every dune. Even if you could hold all of that in your mind, you would still only be grasping a fraction of the stars contained within those galaxies. The numbers are so overwhelmingly large that they cease to function as mere mathematics. They stop being numbers and start becoming metaphors. They become poetic ways of pointing our minds toward an immensity that our brains were never evolved to truly comprehend. What is perhaps most profoundly humbling about all of this is just how shockingly recent our knowledge of it actually is. Barely a century ago, humanity did not even know that other galaxies existed. The prevailing scientific consensus was that the universe consisted entirely of the Milky Way, floating alone in an otherwise empty void. Today, we casually speak of trillions. The sudden, explosive expansion of our perspective in such a short sliver of human history is nothing short of astonishing. It serves as a beautiful, humbling reminder that the cosmos is not just large, but fundamentally larger than we ever thought possible, and that each new tool we build, each new mirror we polish and launch into the dark, reveals an ever deeper layer of reality. And as we count these distant galaxies, a quiet, persistent question naturally rises to the surface. If there are so many of them, how many might host life? How many might cradle civilizations that are looking up at their own strange skies, wondering the exact same things we do tonight? Even if the spark of life is incredibly rare, the sheer brute force number of galaxies makes it almost statistically inevitable that it exists somewhere else. The universe is not just immense in its physical distance, it is immense in its possibility. Every single galaxy is a sprawling, dynamic canvas where stars burn, planets form, and complex chemistry unfolds over billions of years. To count them is to count trillions upon trillions of opportunities for existence itself. And yet, from our vantage point on Earth, we see only the faintest hints of this sprawling reality. The mighty Andromeda galaxy is reduced to a faint, ghostly blur. A few other neighboring galaxies can be teased out of the dark with binoculars or small telescopes, but the rest, the overwhelming majority of those 2 trillion cities of light, are entirely invisible to us, too distant, too faint, revealed only by long, patient photographic exposures and careful mathematical mapping. The night sky, which feels so impossibly full and crowded when you look up from a dark field, is in reality only the thinnest, most superficial layer of what is truly there. The stars you see above you are entirely local. They are our immediate neighbours. The galaxies that lie beyond them are countless. When you finally allow that truth to sink into your bones, it changes the way you look at the sky forever. No longer do you see only a flat dome pierced by points of light. Instead, you realize that behind those stars, beneath them, and stretching endlessly across the blackness, there are layers upon layers of worlds stacked beyond the limits of your sight. Counting the galaxies is not just about tallying up numbers on a page. It is about the profound realization that the cosmos is deeper than our eyes can ever see, and richer than our minds can easily hold. And even this, as astonishing and overwhelming as it is still only one part of a much larger picture, because the galaxies are not just scattered randomly and alone in the dark, they are woven together into massive glowing filaments, connected in the grand architecture of the cosmic web, expanding outward with the universe itself. And so, the question inevitably arises, what is the true size of all of this? What is the actual scale of the observable universe? And how do we even begin to describe a boundary that we can never touch? When you stand outside on a deeply dark night and look up, it feels as though the sky stretches on forever. The scattered stars give the powerful impression of infinity, a grand, overarching dome with no edge, a view utterly without limit. But in reality, there is an edge. It is not a physical wall of stone or ice. It is not a barrier that a spaceship could ever crash into or touch. It is a boundary set entirely by the fundamental limits of light and time. The universe has existed for a finite age, nearly 14 billion years, and light, the fastest messenger in the cosmos, travels at a finite, measurable speed. That simple fact means there is a maximum distance we can possibly see, a hard limit defined by the exact distance light has had time to travel to reach our eyes since the very beginning of everything. This boundary is what astronomers call the observable universe. Beyond it, the cosmos may continue, perhaps endlessly, filled with more galaxies, more stars, and more worlds, but it lies forever hidden from our eyes because the light from those distant places has not yet arrived, and, due to the expansion of space, may never arrive. The edge of what we can see cannot be measured in kilometers or miles, because those earthly units simply collapse under the crushing weight of such magnitude. It is measured in light years, billions upon billions of them. The farthest galaxies we have ever detected lie over 13 billion light years away, their faint, ghostly light beginning its long, lonely journey toward us when the universe was still incredibly young, carrying secrets from the very dawn of time. But, because the universe has been expanding ceaselessly during all that time, the physical distance to those ancient galaxies today is far greater than the 13 billion years their light has travelled. The space between us and them has stretched, pulling them outward, meaning that the true radius of our observable universe is actually about 46 billion light years in every possible direction. Put together, this creates an unfathomable sphere, a cosmic bubble of visibility that is roughly 93 billion light years across. That staggering number is the ultimate size of our horizon, the absolute boundary of the visible cosmos. It is crucial to understand that this horizon does not imply that the universe simply ends there. It does not mean that space stops, or that there is a sudden, sheer drop into nothingness. It merely means that beyond that specific distance, light has simply not had enough time to reach us since the birth of reality itself. Imagine standing in the center of a vast, silent field enveloped in a thick, heavy fog, holding a solitary lantern. The warm glow of your light only extends so far into the mist. You know that beyond the reach of that light, the field continues, perhaps endlessly, but you cannot see it. The observable universe is exactly like our lantern's glow, a boundary set not by a physical wall of fog, but by the relentless ticking of cosmic time. The faintest, most ancient light we can detect from this absolute edge is not even starlight. It is something far older, something more primal. It is the cosmic microwave background, the lingering, cooling afterglow of the Big Bang itself. Nearly 14 billion years ago, when the infant universe was merely 380,000 years old, it finally cooled enough for the first atoms to form, allowing light to travel freely through space for the very first time. That primordial light has been streaming across the expanding void ever since, its wavelength stretched into the microwave spectrum by the swelling of the cosmos, now bathing the sky in every direction, invisible to our naked eyes but glowing brightly to our instruments. When we measure this ancient radiation, we are looking at the universe's surface of last scattering, the oldest light that can ever be seen. Beyond that point, the early universe was an opaque, blazing fog of plasma, a dense wall where no light could escape. This background radiation is the true wall of our vision, the absolute edge of our gaze. The concept of an observable universe is both profoundly humbling and deeply strange. On one hand, it establishes a definitive boundary. No matter how massive or powerful our telescopes become, no matter how perfectly we polish our mirrors or calibrate our sensors, we can never see beyond it. This edge is not a technological limitation that we can engineer our way out of. It is a fundamental limit written into the very laws of physics. On the other hand, the universe beyond that edge may be infinitely larger, stretching out into forever. The observable universe is simply our personal portion, our localized bubble, the specific patch of the cosmos that we are permitted to access. Just like standing on a remote island surrounded by an endless ocean, we see only to the horizon, yet we know with absolute certainty that the sea continues far beyond our sight. To picture this horizon accurately, you must imagine Earth at the exact center of this 93 billion light-year sphere. This is not because we hold some privileged or special place in the cosmos, but simply because the horizon is defined entirely relative to the observer. Every single observer, anywhere in the universe, would see their own unique sphere of visibility centered entirely on them. If you lived on a rocky planet orbiting a star in a galaxy 50 billion light-years away, you would also look out and see a bubble of visibility stretching 46 billion light-years in every direction. Our horizon is not a unique container. It is merely our perspective, a localized window into the infinite. The cosmos graciously offers each observer their own view, their own edge, their own lantern in the dark. Within this colossal bubble lie all the galaxies, the massive clusters, the glowing nebulae, and the delicate filaments of the cosmic web we have spoken of. Yet, even within this localized sphere, there is a profound twist to the nature of observation. The farther you look into the deep dark, the farther back in time you are seeing. Light, for all its blistering speed, still takes time to travel. So, when you peer through a telescope at a galaxy 10 billion light-years away, you are not seeing that galaxy as it exists right now. You are seeing a ghost. You are seeing that galaxy exactly as it was 10 billion years ago, long before the Earth or our Sun had even formed. The edge of what we can see is not only a boundary in space, but a boundary in time. To look outward into the night is to look backward into the deep past, peeling away the layers of history until, finally, you reach the microwave background and the faint, cooling glow of the beginning itself. When you think of travel, whether it is walking slowly across a quiet room or flying in a jet across a vast ocean, there is always a speed involved, a specific rate at which a distance can be crossed. In our daily lives, speeds are incredibly flexible. You can stroll, you can sprint, you can drive at 50 kilometers an hour or 200. Our technology constantly pushes those earthly limits higher and higher. But when you turn your gaze to the universe itself, you encounter a speed that is not just a practical engineering limit, but a fundamental, unbreakable law. This is the speed of light. It is the absolute fastest that anything can move, the ultimate upper bound of motion written into the very structural fabric of reality itself. Light travels at approximately 300,000 kilometers per second. That pace is so blistering, so incomprehensibly fast, that in a single second, a beam of light could circle the Earth more than 7 times. In our daily lives, this speed appears instantaneous. When you flip a switch, the room fills with light without a fraction of a second of perceptible delay. But when you apply that exact same speed to the staggering distances of the cosmos, it suddenly feels finite, restricted, and agonizingly slow. Light from our own sun takes about 8 minutes to reach us. That means every single time you feel the warmth of the sun on your skin, you are feeling sunlight that left the solar surface 8 minutes ago. If the sun were to suddenly vanish, we would continue to orbit an empty space in blissful ignorance for 8 full minutes before the darkness finally arrived. The moon, our closest companion, is about 1¼ light seconds away. The nearest star beyond our solar system, Proxima Centauri, is 4 light years away, meaning the faint glimmer you might seek out in the southern hemisphere began its journey 4 years in the past. Across the span of the Milky Way, light takes tens of thousands of years to travel from one edge to the other. Across the observable universe, it takes billions. The absolute fastest speed possible in nature suddenly becomes a measure of time just as much as it is a measure of distance. What makes this cosmic speed limit so profound is that absolutely nothing, not a physical object, not a particle, not even a whisper of information, can travel faster than light in a vacuum. It is not merely a matter of building a better engine or finding a new fuel source. It is built into the rigid geometry of space-time. Albert Einstein's theory of relativity revealed the beautiful, terrifying truth of this limit. As you accelerate and approach the speed of light, time actually begins to slow down for you relative to the rest of the universe. Distances contract, and the energy required to push you faster begins to rise exponentially. To actually reach the speed of light, an object with mass would require an infinite amount of energy, a condition that nature simply does not allow. For anything with mass, including us and our sleeker spacecraft, the speed of light is forever out of reach, a cosmic tantalization. Only light itself and other massless particles can glide effortlessly at that ultimate velocity. This strict limit explains exactly why the universe has a horizon in the first place. The observable universe only exists as a finite bubble because light has only had a finite amount of time to travel since the dawn of creation. If faster speeds were somehow possible, if information could jump instantaneously across the void, we could see farther, perhaps infinitely far. But with the speed of light serving as the ultimate cap, there is always an edge, always a shadowy boundary beyond which we cannot see. The speed of light is not just a mathematical number to be memorized. It is the very ruler that defines the visible cosmos. It creates a mandatory delay built into the core of existence. We never, ever see anything in the universe exactly as it is in the present moment. We always, without exception, see it as it was. When you look at the moon, you see a second into the past. When you look at the sun, 8 minutes into the past. When you gaze at the Andromeda galaxy, you are seeing light that is 2.5 million years old, light that began its journey when early hominids were just beginning to walk upright on the African savanna. The night sky is not a snapshot of the present. It is a layered tapestry of the deep past, woven across unimaginable distances. The speed of light ensures that space and time are inextricably woven together into a single fabric. To look outward is to look backward. This realization can be deeply comforting in a strange, quiet way. When a massive star violently explodes in a supernova in a galaxy millions of light years away, its brilliant light may just now be reaching our telescopes. The catastrophic event happened eons ago. The star has long since been dead, but for us, standing here on Earth, the event is unfolding right now. We are constantly receiving beautiful, delayed stories from the past, delivered at the absolute only speed they can travel. The universe is a vast, silent archive, endlessly broadcasting its history across the eons, each message perfectly delayed by the immense distance it has to cross. This speed limit also dictates what is physically possible for us as travelers. Even if we could somehow build magnificent starships that approach the speed of light, the distances between the stars are so immense that reaching even our closest neighbor would still take years, decades, or centuries. Voyager 1, the most distant human-made object ever launched, is currently hurtling through interstellar space at over 60,000 kilometers per hour. But even at that blistering pace, it would take more than 70,000 years for it to reach Proxima Centauri. Compared to a beam of light, our greatest machines are merely crawling, inching their way through the dark. The cosmic speed limit serves as a constant, humbling reminder of our true-scale tiny beings on a small planet, moving agonizingly slowly compared to the grand, sweeping motions of the cosmos. And yet, relativity adds a fascinating, almost magical twist to this limitation. For travelers moving at velocities close to the speed of light, time itself slows down relative to those they leave behind. A starship traveling at near light speed could, in principle, cross the void to another star system in what feels like a perfectly manageable amount of time for the crew on board, perhaps just a few months or years. But back on Earth, thousands of years would have passed, civilizations would have risen and fallen, and everyone they ever knew would be gone. The speed of light is not only a limit to motion, but a boundary where time itself bends, warps, and stretches. This is exactly why it is so central to modern physics. It is not just a number on a chalkboard, it is a foundational principle of reality. Nothing outruns light, and in the attempt to approach it, the very nature of time and space fundamentally changes. The speed of light is also the key to understanding why the universe looks the way it does on the grandest scales. As the light from incredibly distant galaxies travels toward us, the very fabric of space it is moving through is expanding. This expansion stretches the light waves, pulling their wavelengths out and shifting them into redder, lower energy colors. This phenomenon, known as redshift, is the primary tool astronomers use to measure cosmic distance and motion. The farther away a galaxy is, the more its light has been stretched, and the faster it appears to be receding from us. But it is crucial to understand that these galaxies are not actively moving through space like ships sailing across an ocean. Rather, the space itself between us and them is stretching, carrying the galaxies along with it like dots drawn on the surface of an inflating balloon. The fact that the speed of light is constant and finite makes this stretching measurable. Without this fundamental limit, we would have no way to map the expansion of the cosmos. Even our most mundane daily experiences depend entirely on this limit. When you look in a mirror, the light reflecting back to your eyes took a tiny, imperceptible fraction of a second to reach you. When you gaze at a star, its light has been travelling for years. When you use a GPS device to navigate a city street, radio signals travel at the speed of light between satellites in orbit and the receiver in your hand, and those tiny, fractional delays must be perfectly accounted for, using Einstein's equations, or the system would fail entirely. The speed of light is not only a grand cosmic principle, but a practical, everyday reality woven into our technology, our navigation, and our perception of the world. There is a certain undeniable poetry in knowing that light itself is both the messenger and the measure. It carries the vital information of the cosmos across the dark, and simultaneously it sets the absolute boundary for how far that information can ever travel. It defines the size of the observable universe, the shape of time, and the physical possibility of travel. Without it, there would be no horizon, no sense of past and present layered beautifully across the stars. And while the speed of light feels impossibly, unfathomably fast to us in our daily lives, on the scale of the universe, it becomes a severe bottleneck. Light crossing a room feels instant. Light crossing the Earth takes a fraction of a second. Light crossing our galaxy takes 100,000 years. Light crossing the observable universe takes almost 14 billion years. Even at the absolute maximum speed allowed by nature, the cosmos is simply too large for direct, immediate contact across its entirety. That vast, unbridgeable gap ensures that a deep sense of mystery remains. That distance is not just a measure of space, but a measure of time. It ensures that the edge of our sight is also the edge of our knowledge. The speed limit of light is not a cruel barrier meant to frustrate our ambitions, but a beautiful feature of reality that gives the universe its very shape and structure. It means the night sky is layered in deep, rich history. It means we live safely inside a protective bubble of vision defined by time. It means that travel and communication are forever local, inextricably tied to the steady, unyielding pace of photons. And it means that even as we build better telescopes and look farther into the dark, we know with absolute certainty that there is always more beyond, unseen, waiting in profound silence. When we speak of the cosmos, we often imagine it as something vast but steady, a great, enduring structure stretched out and patiently waiting to be explored. We think of it as a silent, unchanging backdrop upon which galaxies sit and stars slowly burn. Yet, the universe is not fixed. It is not static. It is wildly dynamic, constantly changing, and relentlessly growing. Space itself is stretching, and it has been stretching since the very beginning of time. This monumental discovery that the universe is actively expanding is one of the most profound shifts in our understanding of existence, because it means the cosmos has a definitive history, a fiery origin, and an unfolding future. For the vast majority of human history, the universe was assumed to be eternal, stable, and completely unchanging. The stars circled overhead in their predictable, regular patterns. The planets wandered through the zodiac but always returned, and the milky band of our galaxy arched across the night sky without any visible alteration. It felt perfectly natural to imagine that the universe itself was permanent, that it had always been exactly as it is right now, stretching back into an infinite past and forward into an infinite future. But in the early 20th century, careful observations began to suggest a very different reality. Astronomers looking at distant, faint galaxies noticed something peculiar in their light. It was stretched, shifted heavily toward the red end of the spectrum. This redshift was not a random occurrence. The farther away a galaxy was, the greater the redshift appeared to be. It was as if all the galaxies in the cosmos were fleeing, moving away from us in every direction, and the more distant they were, the faster they seemed to retreat into the dark. It was Edwin Hubble who, in 1929, finally put the pieces together. He showed definitively that the universe itself is expanding, that these distant galaxies are not racing outward through a static, empty space, but are instead being carried apart as the very fabric of space stretches between them. This was a startling, revolutionary idea. It meant that the universe had not always been this unimaginably large. It meant that if you ran the clock backward, there must have been a time when everything was closer, denser, and incredibly hotter. That singular realization gave birth to the theory of the Big Bang, the profound idea that the universe began from a much smaller, infinitely dense state nearly 14 billion years ago and has been expanding, cooling, and evolving ever since. The mental image of this expansion is sometimes misunderstood. People often imagine galaxies flying outward through pre-existing empty space, like shrapnel exploding from a bomb. But the reality is far subtler and far more strange. It is not that galaxies are rushing outward into an empty void. It is that space itself is expanding, continuously creating more space and carrying the galaxies along with it. Imagine taking a deflated balloon and drawing dots all over its surface. As you inflate the balloon, the rubber stretches, and every dot moves farther apart from every other dot. The dots are not sliding across the surface of the balloon. Rather, the surface itself is stretching, increasing the distance between them. In exactly the same way, galaxies drift apart because the invisible fabric of space is stretching between them, widening the gulfs of the cosmic ocean. This cosmic expansion has been measured with increasing precision over the decades. Astronomers calculate what is known as the Hubble constant, the exact rate at which the universe is stretching. Today, it is roughly 70 kilometers per second per megaparsec, which means that for every 3 million light-years of distance, galaxies recede from us, an additional 70 kilometers per second faster. On the local scale, this stretching is imperceptible, easily overcome by the gravity holding our solar system and our galaxy together. But on the largest cosmic scales, across the vast voids between superclusters, this stretching adds up to staggering, mind-bending speeds. Galaxies that are billions of light-years away are actually receding from us faster than the speed of light. This is not because they are breaking the cosmic speed limit by moving through space faster than light. It is because the space itself expands between us and them at a cumulative rate that exceeds light speed. Their ancient light still reaches us if it began the journey early enough, but beyond a certain critical distance, their light can never, ever catch up to the expansion. They are lost to us forever, slipping quietly outside the observable horizon into the unreachable dark. At first, physicists naturally assumed that this grand expansion might be slowing down over time. Gravity, after all, is an attractive force that pulls everything together. The combined mass of all the billions of galaxies, the sprawling clouds of gas, and the invisible halos of dark matter should logically act as a cosmic brake, slowly but surely retarding the expansion as the eons passed. Perhaps, some theorized, the expansion might even halt completely someday, and the universe could reverse its course, collapsing back upon itself in a fiery big crunch. But in the late 1990s, astronomers studying the light from distant, exploding supernovae discovered something entirely unexpected, something that shook the foundations of cosmology. The observations revealed that the expansion of the universe was not slowing down at all, it was speeding up. Some mysterious, unknown force now called dark energy was actively pushing the galaxies apart, accelerating the stretching of space faster and faster with every passing second. The universe was not only expanding, but accelerating, and it has been doing so for billions of years, driving the cosmos toward a cold, lonely fate. Dark energy remains one of the deepest, most persistent mysteries in all of modern science. It is estimated to make up about 70% of the universe's total energy content, completely dominating the cosmos. Yet, we know almost nothing about its true nature. We cannot see it, we cannot capture it, and we cannot measure it directly. We only see its terrifying effect, the relentless accelerating expansion of reality itself. Some theories suggest that dark energy is an inherent property of space itself, a kind of vacuum energy that arises from the very fabric of nothingness, meaning that as more space is created, more dark energy appears to push it apart even faster. Others propose that it might be a dynamic field that changes over time. Whatever its ultimate nature, its effect on the cosmos is profound and absolute. It completely determines the ultimate future of the universe. Because of dark energy, the expansion will not slow down. It will not reverse. Instead, it will continue indefinitely, accelerating into eternity. Galaxies that are not tightly bound to us by local gravity will drift farther and farther away, their light becoming more and more redshifted, stretching into invisible infrared and radio waves until they fade completely from view. In trillions of years, the accelerating expansion will have stretched the distances so vastly that all distant galaxies will disappear entirely beyond the cosmic horizon, leaving only our gravitationally bound local group visible in the endless dark. Future astronomers, if they exist in that incredibly distant, fading era, might look up into a pitch-black sky and not even know that the universe is expanding, because everything beyond their immediate galactic neighborhood will have vanished without a trace, their light unable to cross the rapidly swelling voids. The cosmos will look unimaginably emptier, not because it is actually smaller, but because the relentless acceleration of space has stretched the distances far beyond the reach of light itself. This chilling reality changes how we must think of the universe we inhabit. It is not a static, eternal museum. It is a dynamic, evolving entity. It had a fiery, dense beginning, and it will have an unfolding, sprawling future entirely shaped by this invisible, accelerating expansion. To live in an expanding universe is to exist in a cosmos that is not fixed, but is constantly moving, carrying us all outward in a vast, inexorable cosmic drift. What does this mean for us right now, resting safely on our small blue world? It means that when we look out at those distant galaxies, we are looking at fading echoes of a time when the universe was smaller and everything was closer together. Their light is stretched not only by the sheer distance it has travelled, but by the expansion of space itself while the light was in transit. A single photon leaving a distant galaxy billions of years ago has been physically stretched along with the fabric of space. Its wavelength has been elongated, its energy diluted, its colour shifted toward the red. This stretching encodes the entire epic history of the universe's expansion, written directly into the very colour of the light that falls upon our telescope mirrors. By carefully measuring this ancient, stretched light, astronomers can reconstruct the deep past, tracing exactly how fast the cosmos was growing at different epochs, mapping out the hidden history of space itself. The discovery that the universe is not only expanding but accelerating stands as one of the greatest surprises in the history of science. It serves as a profound reminder that the cosmos is not merely a vast, empty theatre, but a profoundly active entity. It is not only immense in its physical dimensions, but it is fundamentally changing, evolving with every passing second. The night sky, which appears so serene, so permanent, and so steady to the fragile human eye, is in truth part of a grand, relentless motion. Galaxies are drifting apart, the very fabric of space itself is swelling, and the unseen river of time is carrying everything outward into an ever-deepening dark. And yet, even within this overwhelming cosmic motion, our own little corner of the dark feels incredibly stable. The Milky Way, the Andromeda galaxy, and the other scattered members of the local group are tightly bound together by the invisible threads of gravity. In a few billion years, Andromeda will inevitably merge with our Milky Way, their spiral arms intertwining in a slow, majestic collision to form a brilliant new galaxy. On that relatively intimate scale, the expansion of the universe simply does not matter. Gravity wins the local battle. The expansion only rules on the grander, larger scales, out where galaxies are separated by such terrifying gulfs of emptiness that their mutual gravitational pull can no longer overcome the relentless stretching of space. This dual reality gravity fiercely binding nearby systems together while expansion carries distant ones irrevocably apart is part of the profound, breathtaking beauty of the cosmos. The unsettling fact that the universe is still expanding, and doing so at an accelerating pace, inevitably raises the question of what lies beyond our cosmic horizon. If the cosmos is significantly larger than the observable universe, as almost all current evidence powerfully suggests, then this relentless expansion has already carried vast, unfathomable regions of space beyond our sight forever. Entire galaxies, perhaps entire superclusters and structures more magnificent than anything we have ever mapped, lie silently outside the bubble of what we are permitted to see. The universe in its totality may be infinite. It may be finite but unbounded, curving back upon itself in complex, higher dimensional ways that our minds and instruments cannot yet detect. The expansion hides those ultimate answers from us, sealing them behind an impenetrable curtain of distance and time, locking them forever beyond our reach. Still, the knowledge we do currently possess is nothing short of remarkable. A mere century ago, humanity collectively thought the universe was a static, eternal vault, perhaps only as large as the Milky Way itself. Today, we know it is expanding, accelerating, and unimaginably vast. This is not only a scientific revolution, it is a fundamental shift in the human perspective. To live in a universe that actively grows is to live in a cosmos that possesses a story, a distinct beginning, and a trajectory moving toward an unknown future. We are an integral part of that grand unfolding, carried along with every other galaxy, sailing outward on a silent, invisible tide of expanding space. If the universe is still expanding and accelerating, the natural question echoes in the quiet of the night: will it expand forever? Does it go on without end, truly infinite in its physical size and its duration of time, or is there some other hidden shape, some other ultimate limit waiting in the dark? When you look up at the glittering night sky, the most natural, human question arises from deep within: does it ever truly end? If you could somehow travel far enough, moving faster than light for billions of years, would you eventually come to a physical wall, a definitive edge, a place where the very concept of space simply stops? Or does it continue forever, stretching without limit, without boundary, in absolutely every direction? This is the terrifying and beautiful question of infinity, arguably one of the deepest, most persistent mysteries in all of cosmology. Infinity is a profoundly strange idea because our daily, earth-bound lives never offer us a single genuine example of it. Everything we ever encounter, touch, or experience has distinct, measurable limits. A winding road eventually ends. A heavy book has a final page. A human lifetime has a clear beginning and an inevitable end. Even the earth itself, which once felt endlessly vast to the ancient wanderers who walked slowly across its rugged continents, eventually reveals itself as a round, closed and finite sphere. To try and imagine something with absolutely no boundary, no edge, no final stopping point, is to step completely beyond the comforting boundaries of ordinary thought. Yet, when it comes to the true nature of the universe, infinity may very well be the actual reality we live in. The observable universe, as we have explored, is decidedly finite in its size, It is a spherical bubble, roughly 93 billion light-years across, strictly defined by how far light has managed to travel since the dawn of time. But that specific boundary does not mean the universe itself is finite. It only means that the laws of physics allow us to see exactly that much of it, and no more. Beyond that dark, receding horizon, space may simply continue, perhaps endlessly, stretching into the unknown. The billions of galaxies we can see are only a tiny, localized sample, a mere patch of the unimaginably greater whole. The true physical size of the cosmos may be larger by countless orders of magnitude, or it may be truly, terrifyingly infinite, with no end at all. Astronomers approach this monumental question with extreme care, because infinity is notoriously difficult to test. You cannot measure infinity directly with any telescope, no matter how perfectly crafted. Instead, you must look for subtle, hidden clues left in the light. One such crucial clue lies in the fundamental geometry of the universe itself. Space can curve, bending and warping just as the physical surface of the Earth curves beneath our feet. If the universe possesses a positive curvature, somewhat like the surface of an enormous cosmic sphere, it would eventually close in on itself, rendering it finite but entirely unbounded, much like how you can walk around the globe without ever finding an edge. If it possesses a negative curvature, bending outward like an infinitely flaring saddle, it would extend forever, but with a highly distinct, warped shape. If, however, space is perfectly flat, it could very well be infinite. Exhaustive measurements of the cosmic microwave background, the ancient cooling afterglow of the Big Bang itself, strongly suggest that the universe is remarkably close to being perfectly flat, with no detectable curvature whatsoever on the grandest cosmic scales. That profound finding strongly hints that the universe may indeed stretch into genuine infinity. But even perfect flatness does not absolutely guarantee infinity. The universe could be geometrically flat yet still wrap around itself in a complex, hidden topology, perhaps shaped like a cosmic torus, repeating seamlessly like a wraparound map in a video game, making it endless for a traveler, but fundamentally finite in its total content. Or it could extend only so far before curving in subtle, exotic ways we simply have not yet developed the technology to detect. The overwhelming weight of the evidence points strongly toward a cosmos that is vastly larger than the small, observable bubble we inhabit. But whether it is truly, mathematically infinite remains a tantalizing, open question. Infinity also raises deeply unsettling paradoxes that challenge our very understanding of reality. If the universe is truly infinite and uniformly filled with galaxies, then it logically follows that there are infinite stars, infinite planets, and infinite possibilities playing out in the dark. Somewhere, countless trillions of light-years away, far beyond the reach of any telescope, there could be another Earth, identical to ours in absolutely every single detail, because in an endless infinity, every possible arrangement of matter, no matter how statistically improbable, must eventually occur. There could be not only one, but infinite versions of you, living out infinite variations of your life across the endless expanse of space. This sounds exactly like the realm of wild science fiction, but it is, in fact, a strict, unavoidable logical consequence of combining true infinity with a finite number of ways that atomic matter can arrange itself. If particles can only arrange themselves in so many finite configurations, then an infinite universe absolutely guarantees repetition. This mind-bending concept is sometimes called the doppelganger, or multiverse interpretation of spatial infinity. And while it violently stretches the limits of human imagination, it also beautifully illustrates just how profoundly strange infinity truly is. It is not just a description of something very large. It is a qualitatively different state of reality. It is a realm where probability guarantees endless duplicates, where the very concept of rarity is completely erased by infinite repetition. Infinity also dramatically reshapes how we must think of beginnings and ends. The universe may have started with the fiery birth of the Big Bang, but if the universe is truly infinite today, it was already infinite even in that very first fraction of a second. Every single region of space was once incredibly compressed, dense, and unimaginably hot, but the whole of it still had no edge. The subsequent expansion simply stretched what was already unbounded. Similarly, if the universe continues to expand forever into the dark, infinity remains infinity. It cannot somehow grow into infinity, because infinity has no larger state. It simply continues, endlessly, without boundary or border. There is also the lingering philosophical question of whether infinity is a physical reality or merely a convenient mathematical concept. In the abstract world of mathematics, infinity is perfectly well defined, a clean, endless extension of numbers. But in the messy, physical reality of physics, we must seriously ask whether the universe itself truly embodies this endlessness. Some brilliant minds argue that infinity is not physically possible, that the universe must be finite in subtle hidden ways we have simply not yet understood. Others readily accept it as real, pointing to the unbending flatness of space and the total lack of any evidence for physical boundaries. The debate continues in observatories and universities around the world, and it may never be truly resolved, because by definition, we can never observe anything beyond our own fading horizon. Even without absolute certainty, the mere thought of infinity has a profound, lasting impact on the human psyche. It makes the universe feel simultaneously more overwhelming and far more intimate. It is overwhelming because infinity means there is no end, no outer limit, no final destination where the cosmic journey finally stops. It is intimate because if everything repeats, then every conceivable possibility is eventually realized. Somewhere in the dark, the universe becomes a vast, endless mirror, reflecting infinite variations of the exact same patterns. Infinity also fundamentally changes how we view our own existence. In a finite universe, the Earth might be exceptionally rare, uniquely precious, a single, lonely oasis of life in a vast, dead desert of stars. In an infinite universe, however, Earths might be countless, scattered like glowing pearls across a limitless cosmic sea. Life might not only exist elsewhere, but literally everywhere, repeated in forms both comfortingly familiar and terrifyingly strange. Infinity turns the profound question of rarity into a simple matter of inevitability. And yet, even if this staggering infinity is the true nature of reality, our own personal experience of it remains strictly finite. We live our entire lives within the observable bubble, the tiny slice of the cosmos that light has generously allowed us to see. Our human lifetimes are measured in mere decades, our recorded histories in millennia, our entire species in just a few 100,000 years. Against the crushing weight of infinity, these human scales are vanishingly small, almost non-existent. The great paradox is that we live such brief, finite lives in what may very well be an infinite universe. That sharp contrast is part of the deep wonder of our existence to be so small, so bounded by time and space, yet possessing a mind capable of imagining and describing that which has absolutely no bound. Some find a deep, quiet comfort in the idea of infinity, while others find only a creeping unease. It is comforting because it means there is always more to discover, always a farther horizon, always something beyond the dark. It brings unease because infinity is simply too vast for the human brain to truly grasp, too overwhelmingly large to give any conventional meaning in human terms. But perhaps that is exactly the point. The universe is under no obligation to fit our comforting sense of proportion. Infinity, if it truly exists, is simply part of its raw, unfiltered reality. When you hear the word universe, it naturally feels like the absolute final word, the ultimate container of everything that is, the complete totality of space, time, matter, and energy. For centuries, that was exactly how humanity thought of it. One single cosmos, encompassing all that exists, the absolute sum of everything. But in recent decades, a radical new idea has slowly emerged from the complex mathematics of theoretical physics. It is an idea that is both endlessly fascinating and deeply unsettling. What if our universe is not the only one? What if the cosmos we observe is just one single entity among countless many, merely a small part of a much wider, incomprehensible collection that we now call the multi? The notion of other universes sounds exactly like pure, unadulterated speculation, and in many ways it still is, because we currently have absolutely no direct, physical evidence of their existence. But the scientific community entertains this staggering idea for very serious, mathematically grounded reasons. One compelling reason comes directly from the theory of cosmic inflation, the leading explanation for the universe's earliest, most violent moments. Inflation suggests that in the very first, unimaginable fraction of a second after the Big Bang, the fabric of space expanded at an enormous, exponential rate, far faster than the speed of light, and far faster than at any time since. This brief, rapid inflation smoothed out the cosmos, perfectly explaining why the universe looks so incredibly uniform on the larger scales today. But the mathematics of inflation also predict something else, that this process might not have stopped everywhere at once. Different regions of space could have inflated differently, stopping and starting, creating multiple, isolated bubble universes, each expanding with its own unique properties. In this mind-bending scenario, our entire observable universe, with its trillions of galaxies, would be just one single bubble in an endless, boiling froth of cosmic expansion. Each bubble would be a complete universe in its own right, forever separated from the others by expanding space. Another profound reason comes from the eerie fine-tuning of our physical laws. Our universe operates with specific, unyielding constants, the exact strength of gravity, the precise charge of the electron, the unvarying speed of light that perfectly allows stars to burn, planets to form, and complex life to eventually exist. If any of these fundamental constants were even slightly different, the universe might be a sterile, empty void, completely devoid of any complex structures. Why do they have the exact values they do? Some physicists suggest that if there are many universes, each born with randomly different constants, then it is not surprising at all that we find ourselves in the one where conditions allow for life. In a sprawling multiverse, this miraculous fine-tuning is simply explained by selection bias. We are here, observing the universe, precisely because this specific universe permits us to exist. This staggering idea also arises from the strange, counterintuitive world of quantum mechanics, where the underlying mathematics suggests that every possible outcome of a quantum event might actually occur in some diverging branch of reality. This interpretation, sometimes called the many worlds view, implies that the universe is constantly splitting, creating parallel, branching versions of reality for every single possibility. In one universe, you made a different choice. In another, a distant star exploded a millennium earlier or later. In yet another, the Earth followed an entirely different geological history. These parallel universes, if they are real, would be completely inaccessible to us, yet they would remain a fundamental part of the total, branching structure of ultimate reality. Of course, these remain elegant theories, not proven facts. The immense challenge with the concept of other universes is that, by their very definition, they may exist entirely beyond the realm of human observation. If they exist outside our own expanding cosmic horizon, we can never see them. No matter how powerful our space telescopes become, they are forever cut off from us, their ancient light completely unable to cross the expanding void to reach our eyes. That inherent isolation makes them incredibly difficult, perhaps impossible, to test. And some scientists rightly argue that without the possibility of hard, physical evidence, the multiverse remains nothing more than beautiful speculation. Others passionately counter that if the mathematics of our most successful, rigorously tested theories naturally implies their existence, we are obligated to take the idea seriously, even if direct. Visual observation remains forever impossible. Still, the thought itself is profoundly moving. Imagine for a moment that far beyond the edge of our observable universe, there are countless others, each with its own swirling galaxies, its own burning stars, and perhaps its own forms of life. Some might be comfortingly similar to ours. Others might be radically, terrifyingly different, governed by entirely different laws of physics, containing different forms of exotic matter, or even unfolding in different numbers of spatial dimensions. Infinity could ultimately mean not just endless repeating versions of this specific universe, but endless, unimaginable varieties of universes altogether. It profoundly changes how we must think of our own uniqueness. If there are indeed other universes, then perhaps our cosmos is not particularly special in the grandest scheme. It is merely one of many, a single fragile bubble drifting in a vast, boiling sea of realities. Yet, within it, we remain entirely unique, because this is the specific universe we inhabit. This is the one whose ancient stars warm our faces, whose spiraling galaxies we map in the dark night sky. Other universes may exist out there in the mathematical dark, but they are not ours. This one, with all its flaws and beauty, is the only place where our stories can unfold. Some cosmologists continue to search the sky for indirect, subtle hints of this wider reality. If another universe once bumped or collided with ours in the deep past, it might have left a faint cosmic scar, a subtle, lingering pattern hidden within the cosmic microwave background. Some researchers have tirelessly looked for such ghostly imprints, though none have yet been definitively confirmed. Others search for complex signs in the realm of particle physics, where the existence of extra dimensions or unusual, hidden symmetries could silently hint at a much larger, unseen multiverse. None of this is certain. For now, the existence of other universes remains a haunting, beautiful question, not a definitive answer. But even as a mere question, it possesses an incredible, undeniable power. It stretches the human imagination to its absolute breaking point. It pushes the boundaries of science to its very limits. It makes us confront what the totality of everything truly means. If this universe is not all there is, if it is merely a single fragile note in an endless, unfathomable symphony, then our perspective must shift yet again. We are not only breathtakingly small compared to the vastness of the cosmos, but our cosmos itself might be impossibly small compared to a much greater, incomprehensible whole. The multiverse, if it is indeed real, would be the ultimate, final expansion of scale, a dizzying step beyond even the concept of infinity as we usually dare to think of it. And perhaps, in the face of such overwhelming scale, this is where our innate human curiosity matters the most. Whether or not those other hidden universes actually exist, the very act of asking the question serves to remind us that our own universe is not yet fully understood. There are profound mysteries still quietly unfolding in the dark. The invisible grip of dark matter, the relentless push of dark energy, the fundamental shape of space itself, the ultimate, distant fate of cosmic expansion. To pause and wonder about other universes is not to abandon this one, but rather to see it lovingly in a much wider, grander context. It is to gently realize that everything we currently know, all our maps and measurements, may be only the very beginning of what is truly possible. When you step outside into the cool night air and look up into the dark, you do not see those other universes. You see the familiar, steady burn of stars. You see the distant, swirling galaxies. You see the faint, milky smear of our own galactic home stretching across the zenith. You see only what rightfully belongs to our cosmos, but in the quiet theatre of your thoughts, you can always imagine more. You can picture shimmering bubbles beyond bubbles, infinite layers beyond layers, a sprawling multiverse stretching infinitely beyond the limits of human comprehension. Whether that grand architecture exists or not, the thought itself is a vital part of our ongoing exploration, a beautiful way of reaching far past the physical limits of sight and touching the absolute unknown. This outward journey of the mind naturally, inevitably leads to another question, one that is perhaps even more mysterious and deeply unsettling. How did all of this begin? Where did the universe, or the multiverse, originally come from? What was the true, singular origin of absolutely everything? When you stand quietly under the vast canopy of the night sky, what you see is both impossibly, terrifyingly large, and yet deeply, profoundly personal. The universe stretches away from you in every conceivable direction, filled to the brim with galaxies beyond all counting, woven into massive, glowing filaments expanding outward without any apparent end. Yet, from exactly where you are, standing on a small rocky planet orbiting a perfectly ordinary, middle-aged star, it also feels like something wonderfully intimate, something that belongs to you just as much as you belong to it. This striking contrast between the crushing immensity of the cosmos and the quiet smallness of a single human life is at the very heart of the human perspective. We are, without a doubt, tiny compared to the staggering scale of the universe. The Earth itself is barely a speck of dust against the glowing wheel of the Milky Way. The Milky Way is merely a speck against the sprawling architecture of the cosmic web. Our entire lifetimes are nothing but fleeting blinks compared to the slow, majestic ages of the stars. Great human civilizations rise, flourish, and fall into ruin in far less time than it takes our sun to circle the galactic center just once. On paper, locked in cold numbers, lost in endless comparisons, our physical scale almost entirely disappears. It is incredibly tempting to think that this physical smallness equates to insignificance. It is easy to believe that against a backdrop of billions of galaxies and trillions of burning stars, a single, quiet human life could not possibly matter. And yet, when you pause in the stillness of the night, you realize that perspective changes absolutely everything. Yes, we are physically small, but we are also brilliantly, beautifully aware. We are incredibly rare creatures who can look outward, measure the dark, imagine the infinite, and describe the beautiful. The very atoms that make up your physical body were forged in the crushing, fiery hearts of ancient stars. The calcium in your bones, the iron flowing through your blood, the oxygen you draw into your lungs with every slow breath, all of them were created in massive nuclear furnaces long before the Earth even existed. You are, quite literally, made of stardust, assembled by the slow patience of the universe, and now finally able to look back at the dark and ask what it all is. That is not insignificance. That is participation. The human perspective is not only about our physical scale compared to the cosmos, but about how we actively experience it. A massive star burning billions of light years away is nothing more than a faint, cold point of light to a telescope's lens. But to you, standing in the dark, It can be a profound moment of wonder, a story to carry in your heart, a sudden spark of burning curiosity. A high-resolution photograph of a distant, ancient galaxy cluster is not just raw data. It is a stunning glimpse deep into time, a powerful reminder that the universe existed long before we arrived and will continue its slow dance long after we are gone. That reminder does not diminish the value of human life. It enriches it. It gives a magnificent context in which our days, though admittedly short, feel like a vital, moving part of something enduring and eternal. Consider for a moment the way we have always named and described the sky. Ancient people sat around flickering campfires and traced constellations, drawing elaborate patterns of animals, gods, and heroes across the scattered stars. They told captivating stories to explain their shifting positions, their slow motions, their seasonal changes. They used the turning heavens as a giant calendar, a reliable compass, a trusted guide for planting crops, for sailing treacherous oceans, for simply living. The stars were never just distant, burning suns to us. They were intimately woven into human culture, into deep memory, and into our search for meaning. Even today, with massive telescopes revealing their true, terrifying nature, we still look up with that exact same blend of rigorous science and ancient story. We see both cold data and breathtaking beauty, hard fact and deep meaning. The human perspective is not only about precise measurement, it is also about boundless imagination. This unique ability to imagine may be our single most important link to the cosmos. We cannot physically cross the galaxy, but we can vividly picture it in our minds. We cannot see beyond the edge of the observable universe, but we can conceptually conceive of infinity. We cannot reach out and touch other universes if they exist, but we can endlessly wonder about them. Our minds expand into the dark where our fragile bodies cannot follow. That mental expansion is a fundamental part of being human, part of what makes our physically small lives vast and limitless in their own unique way. At the exact same time, the human perspective is deeply grounded in the familiar, comforting every day. The stars you see tonight are not merely abstract concepts. They are a real part of your sky. You know the shifting seasons you live in, the quiet moments you share with others under that sky. The exact same sky that holds massive galaxies billions of light years away also holds the pale, familiar moon you walk under, the warm sun that greets you in the morning, the simple constellations you eagerly recognize from your childhood. The terrifying vastness and the comforting intimacy coexist perfectly. The universe is both incredibly far out there and right here with you. It is both hopelessly unreachable and intimately immediate. This striking duality shapes exactly how we feel about the cosmos. Some nights you might look up and feel incredibly small, deeply humbled by the crushing immensity of it all. Other nights you might look at the exact same sky and feel profoundly connected, an integral part of a whole so vast and intricate that it naturally includes you. Both of these responses are completely valid. Both are an essential part of what it means to be a conscious human being in a universe like this. The human perspective also includes a heavy, quiet sense of responsibility. We are the only species, as far as we currently know, capable of understanding the universe in this profound way. That makes the Earth not just our temporary home, but the incredibly rare home of the universe's awareness of itself. When Carl Sagan famously called the Earth a pale blue dot, he meant not only that it is vanishingly small, but that it is unimaginably precious. It is the sole, fragile stage on which life and thought currently exist, at least in this quiet corner of the endless cosmos. Protecting it, cherishing it, is an integral part of cherishing the universe itself. And yet, this grand perspective is also incredibly fragile and new. For the vast majority of human history, we lived without ever knowing the true scale of the cosmos. We firmly believed the Earth was the center of everything. The stars hung close overhead like lanterns, the universe a small, comforting dome. Only very recently have we radically expanded that view to include distant galaxies, massive clusters, sprawling superclusters, and the intricate cosmic web. In the incredibly brief span of a single century, our cosmic horizon has exploded from a single, lonely galaxy to trillions of them. That monumental shift is not just a scientific achievement, it is a deeply emotional, cultural, and philosophical awakening. It fundamentally changes how we think about ourselves and our place in the dark. It challenges us to place our true meaning not in physical size or cosmic duration, but in our rare awareness and our rich experience. Perhaps the most profoundly human part of this entire perspective is that we simply never stop asking questions. What lies beyond the absolute edge? Why is there something rather than nothing? How did the fundamental laws of physics come to be exactly as they are? These are not simple questions with easy, comforting answers, but the very act of asking them is a core part of what it means to be us. Countless other animals live in this exact same universe, but as far as we can tell, they do not look up and wonder about it. Wonder is uniquely, beautifully human, a powerful way of connecting our finite, fleeting lives to infinite, endless possibilities. And in that profound sense, the human perspective is not small at all. It is incredibly vast, because through conscious thought, vivid imagination, rigorous science, and compelling story, we effortlessly reach across billions of light years of empty space. We reach back to touch the very beginning of time itself. We boldly speculate about the nature of infinity. We carry the entire, sprawling universe inside the quiet space of our minds. The sheer physical scale may dwarf our bodies, but our unique ability to think about it gives us a kind of magnificent scale of our own. When you stand under the quiet stars, I want you to remember this. You are not a separate thing, standing apart from the universe. You are an integral living part of it. You are a complex, breathing collection of atoms, born in the fiery hearts of ancient stars, shaped by billions of years of cosmic history, alive for a brief, beautiful span, able to see and feel and wonder at the dark. The human perspective is not about arrogantly being the center of everything. It is about being a grateful participant, a quiet witness, a conscious voice echoing within the vastness. And though the cosmos will certainly continue its slow dance long after we are gone, though distant galaxies will eventually drift beyond our view, though burning stars will eventually burn out and massive black holes will slowly fade into nothingness, the undeniable fact remains that right here, right now, in this specific corner of the dark, awareness exists. That rare, precious awareness is you. That awareness is us. In the great, sweeping expanse of time and space, it is merely a fleeting, temporary spark, but a spark, even a very small one, still beautifully lights the dark. You have been drifting for a long time now, drifting through ancient stars and distant galaxies, through glowing filaments of ancient light and freezing oceans of absolute emptiness, through invisible horizons defined by time itself. The universe is undeniably larger than our fragile senses can ever hold, larger than our clumsy words can ever truly capture. And yet, here you are, listening in the quiet, breathing slowly, fully present within it, a living part of the very fabric you have been imagining. The scale has stretched relentlessly outward, from familiar planets to distant galaxies to sprawling webs across billions of light years. And somehow, beautifully, it all still leads right back to you. A single, conscious being resting quietly on a small rocky planet, turning slowly beneath the vast canopy of the night sky. It is so easy to lose yourself in that crushing vastness, to let the massive numbers simply roll past you, the billions and the trillions, the unimaginable distances that stretch far beyond human imagining. They are absolutely real, but they are also just metaphors, pointing at a deeper truth too wide for language. What truly matters in this quiet moment is not just that the universe is immense, but that you have actually felt its immensity. You have bravely carried your mind outward, slowly, step by step, from the familiar, comforting neighborhood of local planets to the absolute, fading horizon of the observable cosmos. That simple act of thought is itself utterly remarkable. No matter how physically small the body is, the human mind can comfortably hold entire galaxies. The night sky resting above you, wherever you happen to be right now, is not an abstract concept. It is the real, physical connection between you and absolutely everything you have heard tonight. The twinkling stars you see are burning suns drifting within our own galaxy. The faint, dusty streak of the Milky Way is the actual, physical shape of our galactic home. Somewhere out there, hidden just beyond your sight, Andromeda is slowly drifting toward us, a future, inevitable encounter written into the slow, gravitational dance of galaxies. Farther still, massive clusters and glowing filaments stretch across the endless dark. All of it exists right now. All of it is incredibly real, even if it remains hidden far beyond your vision. And you, lying quietly beneath that sky, are a part of it all. You might notice, as you think of this, that your breathing has naturally slowed down, that your body feels pleasantly heavier, deeply anchored to the earth, completely safe. The crushing immensity above you is not something to fear. It is the very thing that has carried you this far already. Every single atom of your resting body has traveled through billions of years of cosmic history just to arrive right here in this exact moment. The calcium resting in your bones once lay in the burning heart of a dying star. The oxygen currently filling your lungs was forged in an ancient cosmic furnace. You are not only residing in the universe is residing in you. That deep, fundamental connection makes the endless distance feel far less cold. It turns the terrifying silence of deep space into something deeply familiar, something quietly shared. Imagine, just one last time, the absolute horizon of the observable universe, that massive 93 billion light-year bubble surrounding us in the dark. It might sound vast beyond all hope of true understanding, but within that delicate bubble lies every single galaxy, every burning star, every rocky planet, every breath of air, every quiet sound you have ever heard. The edge is not a violent end. It is simply the gentle limit of our sight. Beyond it, space surely continues, carrying more wonders than we can ever possibly know. But right here, within this specific bubble, life exists. Consciousness exists. You exist. And that, in itself, is extraordinary enough. You might find yourself quietly wondering what it all truly means. All of this crushing immensity compared to one quiet, fleeting human life. The answer is not hidden in the massive numbers, but in the small, quiet moments. The gentle warmth of morning sunlight resting on your skin, the comforting sound of a familiar voice, the steady, reliable rhythm of your own heartbeat, the deep, settling calm of resting in the dark. These simple things are not less important just because the universe is impossibly large. They are infinitely more precious, precisely because they are fleeting, precisely because they are yours. There is a profound, settling comfort in the idea that the cosmos is so much larger than us. It means we are being carried. We are part of a vast, ancient unfolding, and we are not responsible for holding it all together. It simply continues, majestically, whether we actively think of it or not. And yet, by choosing to think of it, we join it more deeply. The human perspective is not about asserting control over the dark, but about finding connection within it. Tonight, simply by listening, you have connected, not by physically traveling billions of light years, but by allowing your mind to travel outward, calmly, slowly, step by step into the dark. As you settle deeper now, you can finally let go of all the massive numbers, the impossible distances, the fading horizons. You can let the swirling images of distant galaxies fade away into something much softer, like the gentle afterglow of a pleasant dream. You have walked far enough into the immensity for one night. You can return now to your own slow breath, your own resting body, your own quiet moment. The exact same universe that effortlessly holds billions of galaxies also holds this quiet pause, this deep rest, this peaceful quiet. There is absolutely no separation between them. You are small compared to the cosmos, yes, but you are also incredibly vast in your ability to imagine, to wonder, to feel profound awe. Both of these truths are entirely real. Both belong exclusively to you, and as you finally allow your eyes to close, you carry both of them with you into the dark. The terrifying enormity of absolutely everything, and the perfect, settling stillness of right now. If this journey has brought you a sense of peace, if it has helped quiet your mind and anchor you in the vastness, I hope you will subscribe, perhaps leave a gentle like, or share your thoughts in the comments when you wake. It helps keep this quiet corner of the universe glowing for others who might be wandering in the dark, looking for a place to rest. But for now, there is nothing left to do, so let yourself rest. The great galaxies will silently continue their slow, majestic drift. The ancient stars will burn brightly and eventually fade into the dark. The universe will continue to gently expand, and here, tonight, you are completely safe within it. You are a vital part of it. You are exactly where you are meant to be. Good night.